Good morning, good afternoon, and welcome
Hello,
to HashiTalks
everyone.
Secure.
Yay! Day two!
How was day one for you, other than speaking?
Oh, it was great. I really enjoyed the talks, and I had a lot of fun learning about all sorts of different patterns from a security standpoint too. I think the one that probably stood out to me, just because that's I have confusion with certificates. I can acknowledge this. I'm really bad with certificates. So there was a nice talk about certificate management with Let's Encrypt and Vault, and it was really nice because it sorted out a couple questions I had about certificates in general.
That's what I like about these talks. We put out a call for proposals, and you hope to see awesome content, but it's always a nice surprise when you actually do get awesome content for these events. We have an Personally, I think we have an amazing community, very very inspiring folks. I see lots of familiar names. Just want to call out a few of them. Hey, Chris, welcome back, of course. And then Shantanu, of course, this couldn't be an event without you. So glad to have you all back and everyone else. So, since this is a community event though, we have to take a little sidestep and talk about code of conduct real quick. It's a professional event. Yes, we live stream it, but that doesn't mean we can be mean to each other. In fact, we'd prefer for all of you to be welcoming, inclusive, and friendly. If you see something that doesn't feel right, let us know. We have moderators in the chat, both on LinkedIn and on YouTube. And just help us make this an awesome event. Truth be told, has never gone wrong. But today is also not going to be the first time.
With that being said, please do interact with us. Say hello in the chat. If you have questions for speakers, comments, or experiences that you have and you wanted to share with us, definitely drop it in the chat. We'd love to hear about it as we go along. Some of the speakers may or may not be in the chat, but if there's a question that you have and you would like it answered, we're happy to forward and follow up for you.
Exactly. All the feedback here can land directly with the speakers. We're also, of course, willing to take product feedback. What you tell us about what you're doing with our products helps us build better versions in the future. So definitely give us that feedback. But with that, people are not here to give us feedback right now. People are here to listen to talks. So who's up first?
Well, we have Christopher Swenson up first. I am really excited for this talk because it's describing the new event system in Vault. If you haven't heard about it, definitely check it out. It's experimental right now, but it has a lot of really interesting use cases that you can think about. Christopher is going to go through some of those use cases as well as how it works. And with that, Christopher, take it away.
Hi, my name is Christopher Swinson. I'm an engineer here on the Vault ecosystem team at HashiCorp, and today I want to talk about the new event system in Vault. So an often requested feature we have in Vault is for some sort of notification system. This way, people can be notified when things like secrets change or are added, or certificates are issued, or some internal pieces change, or plugins are added, or things expire. And there is a feature in Vault called audit logs, and audit logs provides some of this sort of ability. You can, enable audit logs to say be output to a path, and then you get a lot of information about, a particular event that just occurred or a path that was just modified. But it's a little bit inflexible. So they typically look like this. They have a lot of detail. They also have a massive performance penalty. So they're sort of guaranteed for delivery because it's part of the audit system. So it needs to be 100% correct. So there's a big performance penalty sometimes to enabling them. A lot of the detail is maybe things that are not interesting to people, or that are not useful for say a simple notification, and it only is really used by the HTTP system. So it only really refers to HTTP requests and responses. So you don't get like a notification in the audit log that something happened in the background, for instance. But the benefits are, of course, that these are already in Vault, and there's some guaranteed correctness there. So what do events do that audit logs don't? So events are an experiment that was added to Vault 1.13. And they're sort of meant with these goals in mind. So it's meant to be very flexible. So, you can use it however you want to use it. It's meant to be extensible. So it's easy for other pieces of the Vault system or plugins to be able to use the event system. It's meant to be lightweight. So it is not resource intensive to enable it. And hopefully scales well with Vault. It's meant to be non-secret in the same way that audit logs are. You won't actually get the details of the secrets that are happening inside of Vault. So you're not going to see actual data flowing. So they're a little less sensitive than the actual data in Vault. And then another sort of consequence of these is that it's a best effort system, which I'll go into. So events don't have delivery guarantees, and they don't have, exactly. So they don't have, guaranteed one-time delivery or any kind of consistency at this point. And the reason is that this is a first draft experiment, and we didn't want to try to, in one release, rebuild all of a very complex system like Kafka that does support these kinds of delivery, guarantees. Or we didn't necessarily want to replace audit logging, which also has these sort of guarantees. But we sort of wanted to build up to that if it becomes necessary. And also, if you have a little bit of distributed systems background, you'll know that getting delivery guarantees is actually quite a complicated topic. There involves things like the CAP theorem. You typically have big performance impacts. It's not as trivial as just send an event and wait for it to be delivered kinds of things. It's actually, there's a lot of scenarios to take into account. So we're just not there yet. If you do want to explore events, it's really as simple as using a flag in the command line whenever you're starting up a Vault server. And there's also ways to do this from an environment variable or in the config file. And we do have a limited number of events already supported in the KV plugin. So any KV mounts that you have, like the secret mount, will be potentially emitting events if you have them enabled. So you can already start using this as it is, but we're still sort of building out exactly what events we want to support and what we want them to look like. Oops, wrong way. What do they look like? They currently are output in JSON using the cloud events content type, as it says here. So it's basically a really loose JSON formatting where most of our data is in the data section here. And there's also, this is split into the event itself and any other event metadata that are relevant to it. Like if it came from a plugin, which plugin is it? What kind of plugin is it? And also the event type. So this might be referred to as the topic in other systems, but basically just what exactly is it that I want to subscribe to. So if I were subscribing to data rights from KV, it would look something like this. And then the data would come in and tell you a little bit about the data that was written to in this particular case, old version, new version, the path, but not the secret data itself. So the next natural question is, how can we use events? So we see what format they're in from the previous slide. How do we get access to those? And the answer is via WebSockets. WebSockets are a sort of first draft, again, kind of where you can look for events. And we use these mostly because they're currently supported by the Vault API with very minimal modification. They are relatively supported with the current policy system. Like it's basically another HTTP request. So we can reuse a lot of that API machinery that already exists. We can use it in an asynchronous-ish sort of manner. So, you can have a very long-lived WebSocket and keep getting events over it. And it's relatively easy to use with other tooling to sort of build out the use case that you want. So the easiest way to subscribe to a set of events is to use the Vault CLI. So we have an events subscribe command, and you can give this an event type or a simple pattern for what kinds of events you want to subscribe to. So it can be a specific event like KV-v2 data write, or it could be something like I want to subscribe to all KV-v2 events that are happening inside Vault. And then these will basically be output in the format here in JSON format, one event per line, a sort of standard JSON event kind of framework. And so if you want to connect directly, you don't have to use Vault Event Subscribe, and all it is doing under the hood is calling basically out to the WebSocket, either using WSS or WS, and then Vault 8200, and then authenticating to it in the standard ways that you would authenticate, like with a Vault root token or something along those lines. So there's nothing special about this API call other than the fact that it returns a long-lived WebSocket instead of a simple HTTP response. I wanted to give a couple of examples of how you can use this in practice. So for instance, the Vault WebSocket itself is not like, it's great if you just want to like stream it out to a console what these events are going on. But if you want to like integrate with something like, say, SQS, where every time an event happens, maybe in the KVV2 system, I want to get an event on an SQS queue somewhere. So I wrote a quick little Python script, and all this Python script does is it accepts from standard input a line of JSON. And then every time it gets a line, it outputs that to SQS. So this is like sort of the most basic SQS relay system you could build. And then it outputs a nice little message saying, I'm outputting it to that queue. So you tell it which queue, you tell it what region you're in, and then it will copy things from Vault to SQS. You can also build up an integration with Kafka in a very similar way as SQS. So if you have a Kafka topic, in this case it's called my topic, that you want to output events to, you can use the built-in Kafka console consumer script, and it automatically takes messages one line at a time and outputs them as messages in Kafka into the topic that you specify. So we don't even have to build a custom script for this. It already supports it out of the box, doing the same sorts of logic I did here, but built into that shell script. And also I wanted to quickly go over, if you're a Vault developer, it's relatively easy to use this these events within Vault. So I wanted to give a quick example of how you could send an event in your either in your plugin or somewhere within Vault itself if you were modifying Vault. It's really as easy as creating a new event in the logical package. You can then set up any event metadata that you want to package up together as basically a map. It needs to be a JSON object, so from a map. So any kind of key value pairs you want to add into it is fine. You can really put in whatever JSON you want. It's agnostic to that. And then using the backend's send event method. And this will automatically handle if events aren't enabled, then it's not going to send this, and it will automatically send it to the right subscribers and all that stuff. All that logic is handled here. And this happens asynchronously, so this has this send event has a minimal impact on performance. I also wanted to give just a quick demo. I can't resist a good command line demo of something. So the first thing we need to do is start up a Vault server. Just like we had talked about, we need to enable the event experiment either through command line flag or via an environment variable or in the configuration settings. So start that up. I'm running it in dev mode just to simplify matters. And so I want to go ahead and start subscribing to an event. So I will do Vault events subscribe to the KVV2 data write event there. And by default, if we just hit enter, it won't display anything, but it will give us one line per event as they happen. So let's go ahead and generate an event, vault kv put, and then I will go ahead and generate a quick kv there. So this created, a KV item, which we can now see the event about this. And the relevant portions are the metadata. This tells us about the KV information, the KV secret itself. So current version, oldest version, path. And then we get some additional metadata about this was written to the data write event type, and the plugin that generated it was, a KV secret plugin using this mount path. And if we generate another event here, def equals abc, we'll get that as well. So since it was written to the same path, it updated the version of that secret. I also wanted to quickly demonstrate hooking it up to SQS, as we talked about. So I also wanted to quickly demonstrate connecting it to SQS, as we gave the example. So if we do a vault event subscribe, just like we did before, but we can pipe it to our Python script that I showed earlier. This will connect it to an SQS queue. And then we can go ahead and let's go ahead and generate another event. Something equals foo. This generated an event. This was picked up and sent as an SQS message to the event testing queue in this case. And then if I want to read that, I can then read out the SQS queue using an appropriate script. And we can see that SQS queue had a message waiting for me. And it was the event that we saw earlier. And so in conclusion, I just wanted to give a quick summary of what we talked about. So events are available in Vault 1.13 in open source and enterprise editions. So the current events are limited just to the KV subsystem for now. So any KV mounts can generate events. But I did want to emphasize this is an experiment. So we are looking for feedback, and things may change, formats may change, the exact mechanics and performance may change. We try to limit the performance impact as much as possible, but we're still kind of getting all the details ironed out in this system. And thank you very much.
I'd say thank you.
Yeah, that was awesome. And if you want to learn more about the event system, I think Christopher is going to join us for a live stream. So definitely we can hack away and ask some questions there live. Maybe we'll build something too. Maybe you'll see his cat. I don't know. I want to see cats. I like cats on the screen.
I would love for Bonnie to join us. Yeah. On the topic of questions, you ask a really good one. Which concept or tool are we all here to learn more about? I think Chris already answered it for many of us. But which patterns are you looking to learn more about? Which patterns are you struggling with? You mentioned, I think, certificates.
Yeah, certificates. Currently, I mean, it's been interesting to do a lot of work at the Vault SDKs. So how do you retrieve secrets from Vault in applications, right? How do you make sure that you write your application in a way that can handle dynamic secrets? Very different kind of paradigm. Personally, I'm actually interested in intrusion detection. I don't know much about it. That's on the agenda today, and that's pretty exciting. I'm always up for learning new things too. What about you, Kareem?
Not something we have today, but what I'm really curious about is good patterns to solve secret zero kind of problems. Like how do we get the initial AWS key or GCP key into Vault in a sane way? What's the protocol? The technology is there, right? The technology is never the hard part. It's basically a text field that we put something in, an API call we make. But how do we do that securely and reliably?
Yeah, very challenging. So we're excited for you to be here. If you have something specific you want to see from us in the future, definitely drop it in the chat. We've got the setting up Vault with auto unseal sounds drawing me out until you do it yourself. Love it.
I think with that, time for our next speaker.
Hello everyone, and thank you for participating in HashiTalks 2023. Today I'm going to talk to you about why you should use Vault as your Consul certificate authority. My name is Thomas Kula. I am a Senior Staff Solutions Engineer at HashiCorp, and my pronouns are he, him. I've been at HashiCorp for almost 5 years now, and I spent the past couple of years focusing primarily on Consul. Previous to my time at HashiCorp, I did systems and infrastructure engineering in higher education and e-commerce. Bottom of the screen there, you can see my GitHub profile name. Shortly after HashiTalks are finished, I will be uploading not only this presentation, but also all the collateral you need to reproduce the demo environments that I'm going to go through in my talk today. Let's start off by talking about CA usage in Consul. There are two primary uses for a certificate authority in Consul. The first of which is the Consul client auto encryption or auto config. These are two very related topics that are there to help enable or ease the deployment of Consul clients. There's also the Consul service mesh, or what you will oftentimes hear referred to as Consul Connect. Today I'm going to focus primarily on the implications of your CA choice within the Consul service mesh, but the overall ideas are also broadly applicable to the usage of the CA in auto encrypt and auto config. At the core of the Consul service mesh is mutual TLS or MTLS, and this is the case for pretty much every service mesh that exists out there. Every instance of every service on the service mesh has a TLS certificate, embedded in which is the identity of that service. And that's how, on the wire, those services identify themselves to each other. That service identity is used when controlling service access, or what Consul will call intentions. So when service A talks to service B, not only do both sides exchange identity information that happens to be in TLS certificates, but that destination, that service B, uses that identity of its caller and compares it against a list of intentions or access control rules and decides whether or not service A is actually allowed to talk to it. Really what we're asking is, who are you? And both sides of the connection are asking that question. But then in addition, the destination service is asking, are you allowed in? It is comparing the identity of the caller against its list of rules and making an access control decision. And because we are making access control decisions based entirely on identity, and that identity is embedded entirely in TLS certificates, those TLS certificates are very important to Consul, and we need to do the appropriate thing to protect them to make sure that we can actually trust the identity information that is exchanged by both sides. So what do we need to protect? Well, let's start by talking about what we don't care about at all. We do not care about certificates at all. And this may come as a mild surprise, especially if you've done anything with TLS, because a lot of what we think about when we're deploying TLS is how do we manage those certificates, provisioning them, distributing them, renewing them when it's appropriate, but we don't care about protecting them at all. Because a certificate is only an identity assertion, a bit of data that says the presenter of the certificate is, for example, www.hashicorp.com. And instructions on how to verify it. Or, for example, here's how the presenter will prove that it actually legitimately holds a certificate for this identity. We throw around certificates all the time. They are, by design, public documents. And in fact, on the day that I created this slide, here's a command that I ran to ask the HashiCorp web servers, please give me your entire certificate, which it happily did. Your web browser does this all the time whenever you visit a site that is protected by TLS, whether it's the HashiCorp website, your bank, or an online retailer. Again, by design, certificates are public documents. But if we look further in that certificate, we see a section that talks about the subject's public key. And if there's a public key, is there a corresponding private key? And in fact, there is. A given public key has one and only one private key. The holder of that private key can perform a signing operation over a piece of data. And that signature can be verified with the corresponding public key, and only with that corresponding public key. So that allows anyone with a public key to verify that the signature was performed with the private key without requiring any access at all to the private key. And that's how TLS does things. TLS will exchange certificates and will create a signature of over data. That signature created with that public-private key pair, and it's a signature over data that is exchanged during the handshake to prove the identity assertion. This is how TLS works, and that public-private key pair is very important to TLS actually working properly and making sure that the other end is actually the other end. So what do we need to protect? We need to protect those private keys, which, makes sense given the name private keys, something we do not want to share. We care about those private keys because that, again, is what the presenter of that certificate uses to prove that it is the valid holder of that certificate and not some random bystander. But we only know about that public-private key pair because it was in the certificate presented. How do we know that wasn't fake? What's to stop me, for example, for creating a certificate that claims that I am www.hashicorp.com, having in it a public key that corresponds to a private key that I made up and thus know, and then start handing it around? How can we trust the information in that certificate that was presented to us? Well, again, if we look back in the certificate, we see information about the certificate's issuer and the signature over that certificate and the authority's key identifier. And these are all clues on how TLS works to prove that certificates are valid. Because we want to not only be able to verify the certificate, but that it ultimately came from somewhere that we trust. And to do that, our leaf certificates, which are down here at the bottom of this diagram for a particular service or maybe a console client agent, are signed by higher-up CAs, or certificate authorities. And a certificate authority is simply a certificate which signs other certificates. And there may be any number of these certificates going up to a primary root CA. And that's what in Consul we care about. Everything participating in the Consul service mesh knows that primary root CA. And from there, we can build a valid path of trust from that leaf certificate through some number of intermediates up to that primary root CA. And with that, we can figure out how to trust any number of certificates as long as they're in that path. This is what your browser does when you go and visit the HashiCorp website or your bank or an online retailer. Your browser or your operating system has a few hundred certificates that it trusts as root CAs. And as long as there is a path from a certificate presented by a particular website up to something that is a root CA that your local system trusts, we know that that path is valid, and therefore that presented certificate is valid. And so let's talk about what we need to do to protect those private keys. Well, protecting the keys or the private keys of leaf certificates, those actual in certificates for a given service, is fairly easy. First of all, they're pretty low impact. Every instance of every service on the Consul service mesh has a unique certificate with a unique private key. Now, all of the certificates for a given service have embedded in it the identity of that service, but they're all distinct certificates. And when a local Consul agent is asked to create a leaf certificate, it generates a private key locally, creates a certificate signing request, and asks the next layer up to sign our certificate. That certificate comes back. It's public, so we don't care and don't need to protect it. But that private key, which is what ties that certificate to the actual valid holder of that certificate is only ever stored in memory, never on disk, even when local agent caching caches that certificate and that key. And so it is relatively safe. But as we go up in layers, we may encounter intermediate console signing CAs until we get to that root CA, and those are more and more valuable because the signatures of those certificates are responsible for proving the identity of more and more things in the console service mesh. And at the very top is the primary root CA. Again, those are all just certificates which happen to sign other certificates. And especially if we have the root CA certificate's private key, if we have it, we can sign anything, and we can be any service on the service mesh. And so there are best practices. This is recognized in the industry, and there's an industry-wide set of standards established by various standards bodies on how to protect the private keys of certificate authorities, from NIST in the United States, from the CA Browser Forum, from NCSC in the United Kingdom, all talk about, and these are just a few examples of best practices, on how to safely secure those private keys to minimize the chance of a compromise or something bad happening to those private keys. So let's look at how Consul, with the built-in Consul CA, treats its private keys. We're going to go to a demo here shortly, and here are the important bits of configuration. The full configuration is in the presentation repository, but here are the key pieces. And we have a directory where we're telling Consul to store its data. We have turned on Consul Connect, and we have told Consul to use the built-in Consul CA provider. So let's switch to our demo environment and examine the root certificate. And so I have set up a demo environment here where I have set up Consul as its CA, and I'll ask it for the root CA, which again, completely public, so it doesn't need to protect it at all, and I'll get that certificate back. And in that certificate, like we expect, there is a public key section. And again, that corresponds to the private key associated with this root CA certificate. Now, how does Consul store its data? Well, Consul uses the Raft protocol for distributed consensus and to maintain distributed state. When we say that Consul is a highly available replicated service, that distributed state is what is replicated. And I'm not going to go into the details of how Raft works or how Consul's implementation of Raft actually persists data on disk, but there's a few key details here. In my particular configuration, there's a raft.db file in that directory, which is the Raft log, and there may also be any number of snapshots in that particular directory. And the latest snapshot plus that raft.db file combined hold all of the Consul data for that Consul data center. And so what can we find in there? Well, let's go back to our demo environment. We can see that I have that raft.db file. I can see that I've got a couple of snapshots here. I can see that in the latest snapshot, there's a state.bin file. So that state.bin file and that above raft.db file combined represent all of the data that is stored in Consul. And again, I'm not going to go through the details of what's in those files or what the format of those files are. We're going to brute force just look through those two files for anything that looks like it might be a private key. And when I do so, I find something that looks like a private key. But is it a private key for something we really care about? Well, let's kind of pull it apart. I can ask OpenSSL to take that private key and print out the corresponding public key that goes with it. And remember, there's a one-to-one match. Any private key has one and only one public key, and vice versa. And so when I do that, this is the public key that is associated with the private key that we just found. And it is only associated with the public key, or excuse me, with the private key that we found inside of Consul storage. And again, I can go ask Consul, give me your root certificate and show me the public key for it. And when I do so, I can see that these two things match. And because they match, and because of that one-to-one correspondence, what I have found in Raft storage or in console storage is the private key associated with the console root CA. So what does this mean? Well, I have a private key that I found in the console server Raft storage or Raft log. That private key has one and only one corresponding public key, which we just printed out, which matches exactly the public key that is in the console primary root CA certificate, which means this is the key which signs everything. And what's the implication of that? Well, remember, the console service mesh is an identity-based networking tool. We do access control decisions based on identity, not things like IPs and ports. And we connect those services together based on their identity. And the identity is proven on the wire with certificates. And that means that if I have the public key, or excuse me, if I have the private key for the console root CA, and that ultimately is the thing that I'm going to trust to verify the identity of every service on the service mesh, if I have that signing key, if I have that private key, I can be any service on the console service mesh. Again, with this key, an attacker can be any service they want on the console service mesh. Now, how does this change when we use Vault as our CA? Well, let's take a look. I've got a demo environment set up for that as well. Again, these are the important bits of configuration. Here's where my data is stored. I've turned Connect on, but I've also told Consul to use the Vault CA provider. Again, the full configuration is in the presentation repository. So much like I did with the Consul CA setup, I'm going to go look at the Vault CA setup. I'm going to ask for the public key that Consul has. And again, we don't care about this certificate. And so I'm going to print out that console root CA certificate. And again, here is a public key associated with it. So starting off much like we did previously. And okay, we still have that raft.db file, and we still have some number of snapshots. And in that snapshot, there's that same state.bin file. So that state.bin file and that raft.db file combined are all of the storage in this console cluster where we're using Vault as our CA. So much like we did in the environment where we're using Consul as our CA, we're going to brute force look through those files for anything that looks like a private key. And when we do so, we find nothing. Yeah, this is what we just did. We looked through the console Raft storage. So what changes? What changes when we use Vault as your certificate authority in Consul? Well, if I set up Consul to use the Vault CA provider, all certificate signing operations are handled by Vault. And the keying material, which is what we care about, that private key, is stored inside of Vault's cryptographic barrier. No keys ever live on disk unencrypted. Here's a diagram from the Vault documentation that talks about this cryptographic barrier. All of the data that leaves this cryptographic barrier and goes to a storage backend, no matter what storage backend you're using in Vault, is encrypted. So anything that is persisted in persistent storage, disk or anything like that, is encrypted. But what's in Vault storage? Well, let's take a couple of looks here. First of all, I happen to know how to ask Vault, pretty please show me information that normally you wouldn't. And I'm going to go through that fairly quickly. Again, you can follow along with this demo environment after the fact to kind of go through this in more detail. But I can ask Vault, all right, there's a secrets engine that I have configured to be my CA root. And I can ask Vault for, give me a list of the issuers. Basically, these are what private keys are you using in the PKI secrets engine to sign certificates that you're asked to sign. And I can see that there is only one provider or only one issuer, and it's the default one. So remember this string here, or at least recognize it. And I can also get the UUID of this secrets engine. So when I've mounted this secret engine, the Connect DC Vault CA root, internally, Vault kind of keeps track of it by this UUID. And I happen to know, again, Vault, pretty please, show me data inside of your cryptographic barrier. And I can see that information, including the certificate and a key ID. All right, so this is the key ID of the actual key that is being used to sign any certificate in this secret engine by this particular issuer. And remember, there's only one issuer, the default one. And with that, I can ask for the key. And when I do, there's the private key. And again, we're going to go through the same example that we did previously. I can turn it into the corresponding public key, and I compare that against the public key that is in the certificate, and I can see that they match. So if you compare these two values, they match. Now, what makes this different than Consul? A couple of things here. So I was making use of this /sys/raw endpoint in Vault. By default, Vault does not have this endpoint enabled because it violates a lot of Vault's security mechanisms or its security guidelines. Key of which is material only ever really goes into Vault's cryptographic barrier. You can't really ask for it back, especially things like private keys. So when we generated that private key, we told Vault, hey, never let that outside of your cryptographic barrier. But I can turn on this special endpoint and get that data out. But you have to have configured your Vault to be able to do that. And you have to have presented a very privileged Vault token to be able to do that in the first case. I did this primarily to show you that obviously the private key needs to live somewhere inside of Vault because, well, it needs it to produce signature operations, but also to give us a clue of, well, if I have Vault storing its data on disk, let's kind of go look through that and satisfy ourselves that it's not there just in plain text on disk like it is with Consul. And that's what we're going to do next. So I can look in Vault. My Vault happens to be configured to store its data in this path, and I happen to know how to translate the path to show me this actual key. So this is where, when I asked for, /sys/raw, all of this stuff, this corresponds to the actual path on disk where this data is stored. I've configured Vault to store things locally on disk. And I get back a particular value. It's a bit of JSON, has one key that says value, and it looks like that value is base 64 encoded. All right, well, let's decode it. If I do that, I can do, I get that, and I get back, this looks like a lot of binary data. The first 4 octets of which are just a 1. Maybe this is a version number. But if you know anything about certificates, you may know that you can encode things with PEM encoding, PEM, which is a plain text base 64, or you can use DER, DARE encoding, which I don't remember what that stands for, but that's raw binary encoding of that data. And you may know that you can ask OpenSSL to take a binary encoded blob of anything, in this case a private key, and try to decrypt it for us. And so that's what I'm going to do, and I get an error message. So even if we've kind of verified that, all right, well, this isn't a plain text private key. It's not even one of those binary encoded private keys. I'm hoping that I'm close to convincing you that this is actually data that is stored in Vault's cryptographic barrier without having to go into the details of how that cryptographic barrier actually works. So what changes when we use Vault as our certificate authority? Well, we get the security and logging of Vault signing our certificates when we leverage it in Consul. And we keep that sensitive keying material safely protected inside of Vault's cryptographic barrier. So in summary, with the Consul CA provider, the private key is stored unencrypted on disk. With the Vault CA provider, the private key is stored encrypted on disk. We're much happier. So what are the caveats to using Vault as your Consul CA? There's a few. Astute viewers may point out that the token parameter or auth method parameters, if you use that, are stored in plain text on disk. So if I used a vault token, Consul obviously needs to not only know where vault is, but it needs to be able to authenticate to vault in order to ask it to do things. And I may have a token or an auth method where important information is stored on disk. So what are ways of mitigating that? Well, use an auth method which is appropriate for your environment, and maybe one that doesn't hard code those credentials on disk. Maybe one of the cloud IAM methods if you happen to be operating in that kind of environment. But if an attacker on the console server is on the console server and they have either the token or they can use that auth method configured to just ask Vault to do things for me, can I just ask Vault to sign random certificates for me? Well, potentially. Yes, but you also have additional opportunities for audit logging and analysis to detect anomalous behavior. You're also adding a layer of security for attacks on things like backups. Perhaps an attacker doesn't have access to the live console servers, but they've managed to get access to a backup, and maybe that backup is not encrypted properly. We're giving ourselves a layer of protection because we don't have the key, the private key, just sitting there in that backup or that snapshot of the console servers. We may have a token in that backup, so maybe they could use that token, but there are methods that you can use or techniques that you can use in Vault to limit where you can even use a Vault token, so make it harder for the attacker to leverage that token. And what we're doing is kind of reasonable actions to make an attack more complicated and also increase the likelihood of detection, because those are things which will help with your defense. And it may provide additional data in a post-attack analysis to determine the full scope of the compromise, which can be very important. If you can use this additional data, this logging, and things like that to prove that only specific bits of information were compromised, then you can focus your efforts on mitigating the impact of that instead of having to mitigate potentially everything and anything being compromised. This is defense in depth. There's other things that might be useful. Depending on your industry, you may have regulatory requirements that mandate that a private key is encrypted whenever it's persisted to storage, or is never persisted to storage in an unencrypted form. This may also be part of your corporate risk mitigation strategy. I've done this in my career, those 200-page checklists that someone says, all right, you got to check off everything on here before we approve your usage of this thing or before you pass your audit. And I, like anyone who's ever gone through any of those things, certainly have very strong opinions about the actual security that this brings to us. But from a pragmatic standpoint, if you can demonstrate that the private key is never stored unencrypted on disk in storage, you can check that box and move along to using the console service mesh to help protect your security in other ways. So again, we're not talking about absolute security because there is no such thing as absolute security, but pragmatically, you just got to check those check marks off to get the people to sign off on things that you have to have sign off on those things. And using Vault as your console CA may provide you a path to help meet those requirements. Now, there is additional complexity. Using Vault as your console CA does mean more moving parts because console now has a dependency on Vault. If console is unable to access Vault, though, it isn't immediately fatal. Certificates which are still valid will continue to work. They have a lifespan associated with them. But anything requiring new certificates, however, will break, whether that's normal certificate rotation or generating new certificates for a new instance of a service or for a new service entirely. But you can mitigate that. Vault, just like console, can run in a highly available cluster with no single point of failure. So you can get around that. But again, there is management overhead there, however. We're going to end today's discussion about should I do it? Should I use Vault as your console certificate authority? That's the key question here. And I'm going to use the standard weasel out mechanism of saying that is a question that only you can answer. But I'm not being facetious here. It's true. Only you can truly answer whether or not you should use Vault as your Consul CA. Now, I am certainly an advocate for using Vault as your Consul certificate authority. But at minimum, I hope that you have a greater understanding now of the implications of whatever decision you happen to make so that you can make an informed decision to satisfy your particular situation and requirements. I want to thank you again for participating in HashiTalks 2023. There's a link there at the bottom of the screen where this material, so both the presentation and all the collateral, will be uploaded to my GitHub profile shortly after HashiTalks is finished. Thank you again for your time.
I think Shantanu and Rosemary, you had the right idea. Some of this needs to be a T-shirt. It's the only way this can go forward.
I know, right? This is I need this T-shirt, and I probably will keep the screenshot just because I feel like that's it's just interesting. Everybody likes the Twitter on the T-shirt now, like the tweet or the whatever on the T-shirt now, right? So why not? It has attribution built in.
I mean, might be a nice side business. Tech learnings in T-shirt form.
Yeah.
Instead of real security training, you get a T-shirt.
You know, you just read everybody goes to the conference or like the gathering and they just have tech learnings on their T-shirts. I feel like that is a great conversation starter.
So is this the one you would pick for your T-shirt for your next conference?
Probably. Last HashiConf Europe, it was actually legitimately about using Vault as a CA for Consul, and I went down the rabbit hole of bringing my own CA. And I remember I had like 4 levels of intermediates in the talk, and I was like, what am I doing? Why am I here? Why do I have 4 levels of certificates? So I feel like I just need this T-shirt to represent the angst that I was feeling while I was giving that talk. Speaking of HashiConf Europe, I hear we have HashiDays coming up.
We do, and our team will be in several different cities. So this year, instead of just being in Amsterdam, we're actually going to be in London, Paris, Munich, with separate speakers, of course, our team. So Rosemary, I think you'll be in London. We've got Eric and Nick in Paris. I'll be in Munich together with Cole. It's going to be awesome. If you want to meet us, if you want to have a great day, get some limited edition stickers and some very limited edition knowledge sharing and learning from our education engineers, cool new product announcements. Definitely check it out at hashidays.com.
Yeah, Paris is still available. So if you would like to attend in person, register for Paris. There's a security focus there. So you'll be able to learn even more about the HashiCorp tools and how they fit into some of your security requirements. So certainly join us in Paris on June 13th. Otherwise, we hope to hear from you online, and you can always reach out to us. We also have HashiConf Global as well. But certainly in terms of the most immediate event, sign up for HashiDays Paris.
We might even show you a policy on how to protect your croissants.
Now I want a croissant. Thanks, Kareem.
Right? This is a problem.
I
think Thomas brought up a very valid point around audits and the pain you always incur in those processes, no matter how much you plan for it. If you've been in an audit, you know what I'm talking about. If you haven't been in an audit, keep whatever you're doing and don't try to be in one because it's not fun. But our next speaker, Aditya, might have some ideas around this and around making this process a bit better with a talk on how HashiCorp Vault Enterprise helps meet compliance requirements.
Everyone, and welcome to HashiTalks. Hope you're having a great day. So this talk is about HashiCorp Vault, but beyond secrets management. So we all have seen HashiCorp Vault be the de facto solution when it comes down to secrets management. But have you ever considered that HashiCorp Vault is beyond secrets management? Let's see in this talk how enterprises can make use of Vault and actually make them compliant. Yes, that's right. So we will look at HashiCorp Vault and how it helps enterprises gain their compliances in the payment and card industry. So my name is Aditya Sharma. I am a DevOps consultant at Arctic, based out of Toronto, Canada. You can connect with me on LinkedIn. As you can see, my handle is on the screen. I would love to say hi and chat further. So the agenda for this meeting is, as I mentioned, this talk is about Vault and compliance. So definitely both of them are going to be part of this talk. So I will take you through a bit of understanding around what PCI DSS compliance is. Don't worry about the full form of this. I'll explain it in the coming slide. Then, what does compliance really mean for an organization? We have to look through how and when the companies really focus on compliance, and we will see what different teams, different personas within the organizations are and how they perceive compliance. Then we will look at how Vault will do the compliance mapping for PCI 3 using Transit Engine and Transform Engine. Then we will look at how Vault will help in the PCI 7 compliance using different teams and different access to those teams. Then we will look at PCI 10 compliance, which is anything around the card information that is stored, it should be tracked as well. So we will look at PCI 10 compliance and how audit logs help in achieving them. So we are going to run through a scenario where organization is going to achieve PCI compliances, and we will also demonstrate how Vault is going to help them achieve that. Okay, so what does PCI DSS compliant means? So PCI DSS means the Payment Card Industry Data Security Standard. So PCI DSS, it's a compliance that is valid for the organizations who are either storing the information, accepting the information, or transmitting the credit card information. It's a continuous process across the enterprises, across the organizations, where they assess the risks, where they remediate that, and they report it if a risk has to be captured in the audits, and they maintain if that's running fine. So this is a continuous process, and it is a set of some operational and technical standards that companies, especially payment industries, have to comply with. Now, how are the enterprise requirements really coming for this compliance standards? Let's take an example, not looking at the compliances, but let's look at a journey where a company is going through an app modernization practice. So there is an organization who is running a legacy app and accepting payments and running fine, but not always things go as planned. So they have scalability issues, and they are battling with response time. So the organization decides to do an app modernization, take an app modernization journey. So they go with the microservices architecture, implementing all the fancy buzzwords. They implement DevOps. They design the databases on the cloud, setting up all the VRs, setting up the help and support processes a little better. But the most important is they're targeting the security to be in the design phase. And that's the most important aspect of it. Now, when the security is in the initial design phase of an app modernization journey, that's where the real story begins on the compliance. So the CISO, the Chief Information Security Officer, generally puts the guidelines that they need to secure the payment data now. And there are different compliances that deal with it. Specifically in this, we will look at 3 compliances. PCI 3, which talks about securing the data of the consumers. PCI 7, which talks about giving only limited access to the teams that are in really need of that. And third is PCI 10, where every transaction that's happening in the payment industry has to be tracked within that organization. So if you're pulling the data or putting the data into your database on the credit cards, something has to track it. And this organization has adopted Vault. As I mentioned, it's a Vault and compliance thing. So definitely these two are in the picture, and we will see now how HashiCorp Vault, just beyond what it is capable of doing, that secrets management, how it can really handle these 3 compliance requirements. So I'm excited for the talk, and let's get moving. So let's look at the compliance requirements in a bit more detail. So what is PCI 3? As I mentioned, it is securing the credit card information. And when it is stored, you have to make it unreadable. So what does that mean? It means multiple teams will now have to make it work across an organization, right? So the first team is the DevOps. The DevOps team would be entitled to implement more of this strategy. So that means they will implement the encryption on the credit card, and that will be set up using HashiCorp Vault. And within Vault, they will also configure roles and policies so that different app teams can access the data, but with limited privileges. And the second is the application teams. Now, application teams will be the one who will consume this data. So if this is encrypted, they will have to, decrypt that and also put the logics to call different apps altogether and databases. So they will have to enable their apps to connect to Vault Engine APIs. And the major concern around app in this ecosystem is they don't want the things to break. So when the encryption happens, the things break also. So that's their main concern. They want to deliver fast, but they don't want to break stuff. The third team, the second compliance is PCI 7. So in PCI 7, the cardholder data should be limited to different teams. What that means is your database admins, they have control over the databases. They should not be able to view the credit card information as is. It is essentially a point of data breach, and companies have huge penalties when it comes down to any breaches. Second is the support team. Now, support is very critical in the payment industries. Things go wrong, the payments are reversed, customer may have unauthorized activities, but any support that needs to happen, this team really needs access to the data. But do they really need the whole credit card information? Not really. So they need only the last 4 digits. So audit and the forensics teams need access to the whole clear data whenever any unauthorized activity happens. They need to track it and close it. Last, the audit and forensic team in PCI 10 compliance, they need to monitor and track access to the cardholder data, right? So anything that's going in the payment industry where any transaction is happening around cards, whether it is retrieving that information or putting the data back into the database, any transaction has to be tracked. And these are 3 compliance requirements. Let me summarize it up. I know these are not easy to kind of map, so let me summarize it for you. So as part of PCI 3, we need to encrypt the data. So payment services are going to send the credit card information to Vault. Vault will send encrypted or encoded information. So this is where PCI 3 compliance is being met. This data will be written to the database in the encrypted or encoded format. Now, PCI 7 comes in the picture. The PCI 7 says different teams should have different access rights to the data. So the DBAs will only see the encrypted information. The customer would like to see the as-is information, which is the clear text. Help and support would like to see a masked data, only the last 4 digits. And audit and forensic would also like to see the clear text data. On top of that, PCI 10 says they also need audit logs. So this is all in all what PCI 3, PCI 7 and PCI 10 looks like from a compliance perspective. Let me just summarize it, what I just said. So application teams would like to encrypt credit card informations, but minimizing any impacts into the apps. Fraud detection team needs clear text information. Support team needs only last 4 digits. DBAs and app teams need only access to the data, but with the encrypted form. They should not be able to see the real data. And audit teams should be able to see the real clear text format because they need to trace back certain unauthorized activities, so they need access to this data. So having said that, these are all the compliance requirements that organization comes with. I explained how they basically came to these requirements and what each of these requirements really mean. Now, the first is PCI 3, the next is PCI 7 set, and the last is PCI 10. This is important because now we are actually going to go deep dive into the Vault ecosystem. Let's get started. So let's first look at how Vault achieves PCI 3 compliance. The problem is the cardholder data has to be protected. The solution is simple. just encrypt the data when it is at transit or it is at rest. And what really helps in that is a Vault transit secrets engine. So this secret engine has encryption and decryption workflow. Let's just look at that, like how does it really work under the hood? So the payment service basically sends a request to encrypt API where Vault has different policies. This API is passed on with a clear text credit card information. What Vault does is it encrypts that data and return encrypted credit card numbers. This data is then pushed onto the database in the encrypted format. This is how the encryption workflow looks like in Transit Engine. The same thing is now the data is encrypted, but the apps need to decrypt it as well. So the decryption workflow is the reverse of what we saw. So the first thing is the payment service will send a request to the encrypted credit card information from the database. This encrypted form is then sent to Vault, where it is calling a decrypt API for decryption. Vault, based on the policies, will allow or disallow this call on the API. If it is accepted, it will send back the data back to the payment service in a decrypted clear text format. So now we have looked at the transit engine and how it works. Let's look at the demo. So we will be talking about the transit engine. Let's see what has been enabled. So there are no secret engines enabled right now, but we can enable them from the UI. As you can see, we have transit, we have transform, and other different secrets engine that we can enable. Transform is part of the ADP. Transit is not part of the ADP. I'll touch base on that. Now in the secrets, we have seen there's nothing enabled. Access policies, they are all blank. So it's like a blank enterprise vault system. Let's look at how transit engine has been implemented. So there is a script where I've written all the commands and what it does. So the first step is we will enable the transit engine at a path. You can choose any path. Second, we will define an encryption key. Third, we will test how the encryption key works with the credit card information. We will pass that, and we will take out the ciphertext and pass it into the decryption key. So this description key is where the cipher has been passed. Whatever has been encrypted is a cipher. Let's run it. So when we run it, you will see the first step is we have enabled a transit engine. Then we have created an encryption key at the path transit keys payments. This encryption key will be used to encrypt the data as we have passed, and we have received that ciphertext for that credit card information that we passed. And now we have called a decrypt API passing this credit card information, and we have received it back. So what is stored in the database is encrypted ciphertext that you are looking at the screen. So the decrypted text, as you will see, is the same as we had passed for the credit card. So this is where the transit engine has encrypted and decrypted it. Let's look at in the UI. So this is the transit engine that has been enabled. You will see there are two parameters, the keys. As I mentioned, we are creating a payment key. So we are created a payment key where you can see there are different options available. You can encrypt it, decrypt it, you have data key, rewrap, HMAC. We are not going in that depth, but I wanted to showcase that when you create a key in transit engine, there are multiple options that are available. The important point is the algorithm that is used for this encryption is AES-256. This is the version 1. You can rotate the encryption key or edit the encryption keys as well. Now, moving on to the configuration of this engine, you will see it is enabled at the transit path, and you can configure other parameters as needed. So this is about the transit secret engine. Let's read the configuration from the CLI as well. So you can read the key information that we just saw for more detailed information, like what is a type of encryption key that is being used and a couple of other parameters in order to configure it again. So this is about the demo. So we saw that transit engine can encrypt the data, but there are challenges with transit engine that are very important to solve. The major challenge is when we did the encryption, if you have noted, the credit card is the ciphertext enabled for that credit card number is way long. It is no longer a 16 characters. So that means the teams like databases they have to retune the database, they have to redesign the schemas. The other teams like analytics who are reading the data from the databases, they are impacted as well. So what that means is, though we need encryption, but we need to encrypt it by preserving the format of that. So that impact on the applications are minimal. So the solution to that is if we can use a transform secret engine. Now, transform secret engine is part of enterprise license, and on top of that, it is part of advanced data protection module. So we will look at that. So as we saw earlier, encryption and decryption workflow remains the same, but this is part of advanced data protection module. So on top of enterprise license, you have to pay for additional license, which is ADP. It is NIST certified format preserving encryption, which is called FPE. So if you remember in transit, we used a different algorithms. Here we are using something called FPE, format preserving encryption algorithm, using FF31 FP algorithms. So it will encrypt the data, but it will preserve the format of the output, which is same as the input. And one more thing is, this also provides masking capabilities. That means if you have given a credit card number, it will mask any digits that you would like it to be. This is very critical when we are giving support teams access to only last 4 digits. So let's look at how we can implement that. So first, as we saw earlier, we have to enable the secrets engine. We have to now create a role, which is vault policies, and a transformation identifier. So transformation identifier basically where we define what type of transformation we have to do. It can be FPE or masking, what kind of template we have to use for value detection, what are the roles which are allowed to use this particular transformation. Let's look at the demo. So let's look at the Vault UI. So as you have followed before, we have enabled a transit secret engine. We can enable from the UI. There is a transform secret engine available, but I think it's better if you can look at from the CLI perspective. So let's see the script for transform. It's pretty similar. So we are enabling the transform secret engine. Then we are creating a role and a transformation identifier. We are creating a role so that we can attach the transformation now. Now, after the transformation has been attached, we are creating a transformation of type FPE, and this is a command to create it. So now we have an inbuilt template and allowed roles, which is payment that we just created. Now we are fetching the transformation role and we are encoding the data now. We are passing the credit card information for that transformation that we created, and now we are encoding it. So if you see, we are passing that information, fetching whatever has been encoded, and then finally decoding it into clear text as well. Let's see in action. So let me give the permissions. So let's run the transform script. So transform script has been executed. So as you can see, the role has been, secret engine has been enabled. A role has been created of type payments. We have created a transformation of type FPE and allowed the role payments to be eligible. Reading it, we can see it's a type FPE and it is using a template and allowed role. It is encoding the credit card number with text and it is decoding the, so the important point is it has encoded, but different string is not there now, and it has decoded into the right values as well. Looking at the UI, so you will see there is a transform secret engine. There is a transformation that we just created, which is card number. If you click on that, it is of type FPE, format preserving encryption, and it is using a template of credit card number and a role or payments, which is attached to that transformation. So in the application, you will use this role when you are running your Spring Boot apps. It has 2 built-in templates, but you can also create more templates. There are different alphabets available that you can use within your transformation, and then you can see the configuration of that data specific path. So the most important is the transformation and the roles and how they both are kind of tied together. That's the most important thing. So this was the transformation engine. So we implemented the encryption, and now we can say that the organization is PCI 3 compliant. So we basically protected the stored cardholder data by encrypting it. Without preserving the format, we could have used transit secret engine, but with preserving the format, we could have used transform secret engine. Transform secret engine is part of the ADP module as part of Vault Enterprise license. So let's move forward. I think we have covered quite a bit of ground already. PCI 3 is done. Let's move to PCI 7 now. So the PCI 7 states that we need to limit access to the data for specific team requirements. So what that means is the DBAs should only see the encrypted data. That's something which we have done already. But the support team should only be able to view the data for last 4 digits of credit card. For that, we will use the same transform secret engine but with masking capabilities. Let's look at that. So how do we implement the masking capabilities in transform engine? It's pretty similar. We enable the secret engine. We create a role and a transformation identifier. We create a transformation by giving a different type now, which is masking. We can use a template for value detection. As you can see, there are some default templates, but you can also create a template. So I'm creating a template with a regex. We can pass it, or we can use pre-built templates also. So we can use which masking characters to use, and most importantly, which role to use. This role is used in the applications that you configure. So Spring Boot apps would have application.properties that would refer that way. Let's look at the demo. So in this demo, we will first look at the UI. As we saw earlier, transform engine has already been enabled. We have just one transformation and one role. There are pre-built templates and we can also create one. There are pre-built alphabets that we saw. Now, the most important thing as part of this is we are going to create different roles and different transformations and also new templates. So we are going to create new templates on top of that. So let's look at the CLI. So we have a script that does that. So the first step is we check if the transform secret engine is enabled, which is already done. So we will check if that is there. Then we will create a template. We didn't create a template last, but now we will create a template to mask and with providing a regex and alphabets there. Now, once that is done, we now attach it to the role. We create a new role for cust support because that team would be given this particular role for this transformation. Then we create the transformation for masking the credit card numbers. We give type as masking. We give template that we just created in step 2. Then we allow that role for customer support to only access this particular transformation, and we pass masking character as X. Now we read the transformation rule, and finally we are encoding that. So whenever we pass the credit card information, it is encoded and send only the last 4 digits. Let's look at that. So as you can see, the transform engine is already enabled. We created a template called masked all last 4 card numbers. We created a role for customer support and we attached that transformation of type masking and added that role there. Now fetching it, you will see the allowed roles, the type of masking, the template that is being used. The most important is we passed the credit card information and it returned the masked characters. So this is how the masking would, based on how we provided the template, it will mask only keep only the last 4 digits but mask all. Let's look at the UI. So you can see there is a new transformation added called cust support, and in that cust support you will see a transformation is linked to a role which is masked card number. So that is a transformation which is of type masking. Masking character is X and a template that is used for masked all last 4 card numbers. And you will see that if we go back to the template now, a new template has been created, which we just did. So we provided a pattern on how it will pick up the characters, and based on this template, it basically masked it. Looking at the configs, so this is the same transform engine, nothing new. So the most important is, different transformations you can create and different roles you can create for your different teams, and use that in your application.properties in Spring Boot application, for example. So, having said that, we are already through with PCI 3 and now we are done with PCI 7 as well. Let's look at what we did. So we configured limited access to the cardholder data to different teams now. So the customer team only now looks at last 4 digits. And how we did that is using transform secrets engine masking. Now last, let's look at how Vault will do the PCI 10 compliance. So PCI 10 compliance means you have to monitor and track all access to cardholder data. The solution is you will enable audit devices in Vault. So let's look at how we do that. So what is and how we implement Vault audit devices? So Vault audit devices, first thing is they basically enable you to capture your logs at any path, and those logs can then be shipped to any of the log ingestion tools. So the first step is we enable an audit device in Vault. We send the logs to any platform of your choice. Let's take an example of Splunk. You can also use few things like Azure Sentinel or so on and so forth. There are different tools that can help in processing the data. And finally, the data is there, but the teams have to identify patterns so that any breaches that happen are automatically detected and acted on. Let's see a demo on how that works. So let's look at a script that is written to showcase what is done. So first we are enabling an audit device at a file path, which is writing the logs into vault audit.log in the same host where it is running. It's basically a container. Then we are requesting a mask on credit card for the cust support role that we just did. So we are encoding it, and last 4 digits are only displayed. Then we look at the audit logs in that container where these logs are stored. We'll grep on encode. Then we look at the encryption of credit card using transit engine. So we enabled both. So let's look at how transit engine has received a request and is it captured in the logs or not. So we are doing transform request and transit request, and then we are seeing that if it is captured in the logs or not. Let's run this. So here it is. So if we see, we enabled the audit device at path file. We send a request for masking the credit card number, and it has sent back the response, masked it. Now, this is how the audit log works. So if you see, any request that goes into Vault is captured as a request and a response. So word of caution, we have used the policies as root. It is not advisable. Only for this demo I have done it. You have to respect the policies. Then you will see a response captured as well, where it captures the client token, accessor, and a request ID. So all this information, when it is passed into Splunk, will be captured along with the operations and the path that we have requested. Let's look at the next step, where we have encrypted a card number using transit engine in a ciphertext. And now you will see the same thing, where we are capturing the request for transit, and the client token policies are all captured here. Again, you shouldn't use root policies, so we have used transit engine, the remote address, and the response is captured as well. And we will see that when this is passed, the request, response, everything is passed into the Splunk database. This can be leveraged into different dashboards, and actions can be taken. So that being said, PCI 10 compliance is achieved using Vault, so you are able to monitor and maintain audit logs for every transaction that is happening for your credit cards. In case of any unauthorized activity, this information is really useful for audit and forensic teams. All right, I think we are at the end of our talk, and so the talk was how Vault helps enterprises achieve PCI DSS compliance. So using Vault, we did PCI 3 compliance, we did PCI 7 compliance, and we did PCI 10 compliance. So that's the core view of this talk, that HashiCorp Vault is not just a secrets management system. It has way more capabilities, and it caters to a lot more industries who deals in payment industry, and that kind of covers every industry right now. So HashiCorp Vault is way beyond secrets management. I thank you for your time, and I wish you a great rest of the day, and I hope you got some learnings out of this talk. And if you would like to connect with me, my LinkedIn handle is right there. I would love to say hi and chat further. Thank you so much.
I think the kindest thing is always when speakers thank us for listening, and it's like, you just presented half an hour of solid training that companies would normally charge you a lot for. I'm going to say thank you. Thank you to all of our speakers, the ones from yesterday, the ones from today. Without you, we couldn't do this.
Oh, definitely not. And also, I really appreciate how well organized a lot of these topics are. They're very technical concepts that sometimes, you do need to articulate it in different ways, organize the content in a way that is more consumable. That's outside of the HashiCorp documentation, outside of what anybody else might present. So I particularly appreciated Aditya's approach to, okay, here are all the PCI compliance requirements, step by step. These are the ways that Vault would meet them should you use it. So that was really helpful to me.
I also always appreciate folks who write regular expressions on screen with conviction. That takes skill. That is a legit old school skill that you don't see as much anymore.
Oh, definitely. All right. So the next talk we have is going to be really interesting. It is about a data privacy vault, not the same as HashiCorp Vault, but a data privacy vault. I'm curious to hear what it is and how it can help. Let's hear from Adam Chan, a developer advocate at Skyflow, about infiltrated, yes, PII exfiltrated, no.
Welcome to this session called Infra Infiltrated Yes, PII Exfiltrated No. Before we begin, I'd like to show you a short but hopefully powerful demonstration of how easily an attacker could gain access to sensitive information within your infrastructure. Please pay close attention. Imagine we are hackers and our target is a financial institution called Financial First. We're going to target their front-end web page with a login form to gather some information. As with any attack, the first step is to always gain some information about as much information as possible about the target so that you can identify potential attack vectors, which include the backend server, the front end, the database, and anything in between that might be related to the service that could give us some clues on how to gain unauthorized access. Let's head on over to our target's webpage, financialfirst.com. And from there, let's go check in the login page and see if we can learn about the requests that are being made to some backend. Let's open up the inspector and make a request by logging in with some dummy credentials. We just want to see what the network tab will show. And we see that a request is being made to some endpoint/API/login at a coincidentally the same domain as wherever the front end is being served from. And now with the domain name in hand, let's perform an NS lookup to find the IP address of this server. And we can see that it's 10.211.55.8. Okay, so we're making great progress here. Let's explore some potential vulnerabilities that the server's infrastructure may have. We can start by looking for open ports. And to do this, we can launch an Nmap scan against the server, probing for open ports on the machine. Let's spin up my instance of Kali Linux. If you haven't used Kali before, Kali Linux is a Debian-derived Linux distribution designed for digital forensics and penetration testing. Now that we're booted into Kali, let's kick open a terminal and issue the following command. Sudo nmap-p-10.211.55.8. Nmap is a popular open source tool for network exploration and security auditing. The -p- flag instructs Nmap to scan through all ports from 1 through 65.535 at the address 10.211.55.8, which is the target IP address we discovered moments ago. Disclaimer. Before I execute this command, I just wanted to say that using tools like Nmap to scan servers or networks without the explicit permission of the owner may be illegal in certain jurisdictions. Unauthorized use of Nmap or other similar tools could result in criminal charges or other legal consequences. Please ensure that you have the necessary permissions and that you adhere to the applicable laws and regulations before attempting any kind of network scanning activity. The demonstration in this video is for educational purposes only and should not be replicated without the explicit permission and authorization. Okay, let's keep going. The Nmap results reveal several open ports, including the typical Postgres database port, SSH port, and of course HTTP and HTTPS. So we have some information on hand now which could be used as potential attack vectors for us. And who knows what other vulnerabilities that this service may have from not being fully updated or having some other unsafe server configuration. The easiest thing that we can do at this point is to attempt various username and password combinations. According to an article published on Zipia in 2023, 80% of hacking breaches are related to some password issue. This shocking statistic doesn't just end here. 59% of Americans use their name or birthday in their password. And here's another shocker. 57% of people who have been a victim of a phishing attack still have not changed their password. So, knowing this, I have here a basic script that iterates over the most used username and password combinations and attempts to log into the SSH service and Postgres database. The username and password list just came from a Git repository I found online, and it has hundreds and hundreds of common usernames and passwords. This script will run through an n-squared operation, attempting all passwords with every username, creating all sorts of combinations, and if there's a successful attempt with any combination pair, the script will print out what service, SSH or Postgres, and what username and password pair was used to allow us into the service. The script will then quit. All right, we got a hit on the database with username and password combination Postgres password 2023. You've got to be kidding me. Let's create a connection in a new terminal window and see what databases are accessible to us. Great, it looks like we have access to the primary database. And what tables do we have access to? Aha! There's a table here called Credit Report. Let's see if we can get in and do a select star on this table to see if we can find anything of interest. Well, this looks like it's a ton of sensitive PII for a host of individuals across the platform with information such as their names, addresses, social security numbers, and more. My HashiTalks friends, as you just witnessed, it only took a few simple steps to breach the security of this financial institution and expose tons of sensitive information. In fact, this is basically what happened to Equifax in 2017, where their database was breached due to a bad username and password combination that were not particularly set too well. You can do some research and find out some more information about it, but the gist is that the database of approximately 147 million people, which included social security numbers, names, addresses, and tons of other information, were breached and exposed to the world. You don't want to be in this situation as a developer. But before we proceed, I want to assure you that this demonstration that you just witnessed was entirely fictitious. No real data breaches occurred, and all information displayed was of made-up individuals for the purpose of this demonstration. However, it does serve to illustrate the potential ease with which an attacker could gain access to sensitive information if proper security measures are not in place. It's important to note that the demonstration was a simplified version of what a hacking attempt might look like. It's designed entirely for the sake of brevity and clarity. In reality, hacking attempts can be far more sophisticated and complex, involving multiple steps and many advanced techniques to infiltrate a target's system. This only underscores the need for a strong infrastructure and a comprehensive security posture to protect and reduce the risk against such threats. All right, with this out of the way, let's get into 7 steps you can take to reduce the risk of a data breach. And some of these are more obvious tips, while others will take a bit more time for us to fully explain and talk through. At the end, we'll look at how a data privacy vault can help you achieve your goals, ensuring that your organization's sensitive data remains safe and secure. The first thing that you can do is make sure you have a very good understanding of the data that you're currently collecting or intend to be collecting in your project. PII, or personally identifiable information, is any data that can be used to identify a specific individual. Examples of PII include name and addresses, phone numbers, email addresses, social security numbers, driver's license numbers, and passport numbers. Identifying and classifying PII stored in your database is a critical step in improving your security posture because it enables you to understand the types of sensitive data you're storing and where it is located. This information can then be used to apply appropriate security controls, such as access controls and encryption, to protect the data from unauthorized access, use, or disclosure. By understanding the data flow within your system and where PII is being used or exposed, you can also identify potential vulnerabilities or weak points in your system that could be exploited by hackers. For example, if PII is being transmitted or stored in an unencrypted format, it is at risk of being intercepted or accessed by unauthorized parties. We're going to go into this in more detail shortly, but by implementing appropriate security measures, such as encrypting PII during transmission and at rest, restricting access to sensitive data, and regularly monitoring your system for unauthorized access or unusual activity, you can reduce the risk of data breaches and protect your organization's reputation and financial well-being. The second step you can take is to identify whether the information you're collecting is really needed for your business function. If you don't really need it, why collect it in the first place? Or if you don't need it anymore, why keep it around? Data minimization is the practice of collecting and storing only the minimum amount of data necessary to achieve a specific purpose. This helps to reduce the risk of a data breach and other security incidents by limiting the amount of data of personally identifiable information that your organization collects and stores. So why is data minimization important for security? Well, there are several benefits. First, by minimizing the amount of PII you collect and store, you can reduce the risk of a data breach. Secondly, it can help comply with data protection laws and regulations such as the European Union's General Data Protection Regulation, or more commonly referred to as GDPR. Finally, it can enhance your privacy protection and help you build trust with your customers. So now, let's look at some real-world examples of companies that have implemented data minimization practices. And one of these companies is Google. Back in 2019, Google introduced a new feature called Auto Delete for its users' location history and web activity data. This feature allows users to automatically delete their data after a set period of time, such as every 3 or 18 months. So how can you implement data minimization in your own organization? Here are some best practices to follow. It starts off with data classification, as per our previous point of discussion. Identify the types of PII your organization collects and stores. Determine the minimum amount of data needed to achieve your organization's goals. Implement policies and procedures to ensure that data collected and stored is only needed and only used for as long as necessary. Regularly review and update your data minimization practices to ensure compliance with data protection laws and other regulations. As we know, code changes are inevitable in the world of software development. Sometimes we run into bugs that just need to be fixed, or new product requirements force developers to introduce new code or new dependencies. Believe it or not, code changes can introduce swaths of risk that can impact your security posture that may impact how you ensure privacy of your data and your customers. Some things you want to keep in mind whenever you introduce a code change. Insufficient testing can lead to unintended side effects and create security loopholes. If you're touching a part of the stack that interacts with some kind of secure data source, it's best to have others look over your change, and if you have security specialists on your team to evaluate these changes and why they must really be made, then definitely include them in the discussion and the review process as well. Human error is more often than not the cause for many data breaches and security vulnerabilities. New bugs or misconfigured settings all can potentially expose sensitive data or create weaknesses for attackers to exploit. Emphasize a culture of code review within your organizations and ensure code changes are adequately reviewed by peers and security experts. Be mindful of introducing new libraries or dependencies, as they all can carry their own vulnerabilities, which may result in your application inheriting the vulnerability too. As complexity increases and your codebase grows in size, it becomes increasingly challenging to maintain and secure. Try to keep things as simple as possible for as long as possible. This one is painstakingly obvious, but it's always good to call out: don't ever commit any API keys of any sort to any source control, ever. You should be using tools like HashiCorp Vault to secure your secrets, for example. And if you're not familiar with Vault, it's a secrets management tool designed to securely store and tightly control access to sensitive data such as API keys, passwords, tokens, and certificates. So how bad can a code change mess things up? In 2020, the SolarWinds attack was a high-profile, sophisticated hack that affected many US government agencies and many more private companies. The attackers inserted a backdoor into the SolarWinds Orion software, which was distributed to thousands of customers. The breach was a result of malicious code change that went undetected, allowing attackers to gain access, of course in an unauthorized manner, to sensitive data and systems wherever Orion was distributed to. Finally, in 2022, SolarWinds agreed to pay $26 million in settlement against the class action lawsuit. Staying on top of code changes can help maintain privacy for users, reduce risk of change, and reduce the possibility of insane data breaches like this. Data encryption is a critical aspect of data security, as it helps protect sensitive information from unauthorized access and potential data breaches. It involves converting plain text data into ciphertext, which can only be decrypted by those possessing the appropriate decryption key. If you're dealing with sensitive data which you think might be detrimental if ever leaked, just encrypt it. Oftentimes, you may be required to encrypt some data to comply with industry regulations such as HIPAA, GDPR, or PCI DSS. Other times, you may be doing it to protect intellectual property, ensure customer trust, or prevent unauthorized access in general. Improving access controls is a crucial part of enhancing data privacy and strengthening your security posture. This topic of access controls is a big one that goes well beyond the scope of software access to data. It can technically be part of how users access an application and have access to data, and what they can do to mitigate risk as well. Access controls determine who can access specific resources and what actions they can perform, thereby helping prevent unauthorized access and reduce the likelihood of a data breach. Here are some things you can do to keep in mind as you approach access to data within your systems. Implement the principle of least privilege access. Grant users and applications the minimum level of access necessary to perform their tasks. Introduce a regular review process and update permissions to ensure that they align with changing roles and responsibilities. Use role-based access control, or RBAC. Role-based access control assigns permissions to roles rather than individual users. This simplifies access management and makes it easier to enforce the principle of least privilege. For example, the front desk receptionist at the doctor's office doesn't need to have access to every detail about my profile that my doctor would have access to. There's basically no reason they should have my full date of birth or entire medical history. On the flip side, it's understandable why the doctor is going to need it. Making some infrastructural changes to your application is not for the faint of heart, and it could be quite the significant engineering lift. Putting sensitive data in a separate data store in a zero-trust environment isolated from the rest of your application can significantly improve your security posture. Having a separate environment allows you to implement all of the previously discussed ideas, from fine-grained access controls, data encryption, reduction in risk via code change, and things we didn't talk about in detail such as monitoring and logging, into the secure environment. This separation of concerns helps you be more effective in understanding who is accessing your secure environment and how they're doing so. If your main application was under some kind of security breach, your separate infrastructure holding your sensitive data may not be impacted at all. And this is just to say that a separate environment may reduce the impact or reach of a data breach. Building this out can also simplify compliance regulations as well, because it enables you to enforce stricter security controls and audits to be confined to a smaller part of your infrastructure instead of the entire application. This is actually an increasingly common engineering effort in the industry and is becoming more widely known as a data privacy vault. Netflix, the streaming giant, has adopted a microservices architecture to isolate and secure different components of its infrastructure. By segmenting its network and implementing stricter firewall rules, Netflix has enhanced its security posture, making it much more difficult for attackers to compromise its systems and gain access to sensitive data. As we've seen through these real-world case studies, enhancing your organization's security posture can involve a significant amount of work and effort across various aspects of your infrastructure. Implementing all of these best practices requires time, resources, and continuous monitoring to ensure that sensitive data remains protected. However, there is an alternative solution that can help you offload the liability, the engineering work, and stress associated with securing your sensitive data. Skyflow's Data Privacy Vault offers a battle-tested solution designed to handle these challenges on your behalf. Skyflow is a zero-trust data privacy vault built to radically simplify how companies isolate, protect, and govern their customers' most sensitive data. Effortlessly meet GDPR, Schrems to BDSG, PCI, HIPAA, and data residency requirements with simplicity and flexibility, and eliminate PII data sprawl with Skyflow. And by leveraging Skyflow in your infrastructure, you can streamline your security efforts and enjoy greater peace of mind, knowing that your organization's sensitive data is being protected by a robust and tried and true system. Thank you so much for your time today. I hope you enjoyed this session. If you want to learn more, please come over to skyflow.com/get-demo today.
I think somebody mentioned this in the chat before. IT security is very much about knowing all the right acronyms and knowing which protocol you have to follow at this point in which country and continent, and well, that. It's hard. I'm glad for content like this that makes it slightly more palatable, and really love the disclaimer. How about you?
Yeah, I appreciated the demonstration. I know some folks were asking like, oh, how do I get more information about this? Where do I find the scripts? Again, follow Adam's disclaimer, please. Don't do this necessarily yourself without any authorization. But if you are interested in learning more or you want to follow up, do reach out to Adam. The videos from HashiTalks today, as well as yesterday, will be posted in a HashiTalks secure playlist on the HashiCorp YouTube channel, and the speaker slides will be posted on Discuss forum. If you go to the forum and you search for HashiTalks Secure, there is a thread opened for slides. So definitely, if you are interested in replaying or seeing a session you missed, go to the playlist when it is finished and then go to see the slides on Discuss.
And so if you're not interested in replaying, but actually contributing as a speaker, we have many more HashiTalks planned this year. So head on over to the URL that we're going to pop up at the bottom. So hashi.co/hashitalks-hub, and see all the events that we have planned for the rest of the year. Some of them are theme specific, like secure, build and deploy are two of them. And then of course we have regional ones. So whatever kind of story you have, step up to the proposals form, send in your idea, and let's hear your story and your learnings. Somebody who did that was Dwayne. Dwayne spoke at HashiTalks Deploy last year in December. Super amazing talk. Definitely worth rewatching. I'm not going to spoil it because it's just too good. But Dwayne is back. And today he's going to talk about actively detecting intruders with cyber deception tools. Dwayne, over to you.
Everybody, welcome to my talk, Who Goes There? Actively Detecting Intruders with Cyber Deception Tools, here at HashiTalks Secure. Very happy to be here. So I'm Dwayne. I live in Chicago. I've been a developer advocate since about 2016. You can find me out on the internet at MC Dwayne, over on Mastodon Social at MC Dwayne as well. I'm there a little bit more than I am Twitter these days, but hit me up on either. I'm always happy to chat about anything I talk about tech-wise, or outside of tech. If you want to talk about improv, karaoke, crochet, knitting, or going to rock and roll, hit me up. I'm always happy to chat about that stuff too. Very quickly, I work for a company called GetGuardian. We're a code security platform. We help people figure out where their hard-coded credentials are throughout their source code and if it's been leaked or not. We do make a honey token product. We do have an open source product as well. We'll mention those. I'm not here to sell you on those. I'm here to sell you on the idea of cyber deception to stop your code leaks from happening and to let you know that an attacker is attacking you. So what a problem are we talking about? Well, I'm going to talk about some scary stuff here for a second. So if you do feel a little overwhelmed, like, hey, wow, you're telling me horror stories to rile my blood, just recite the Bene Gesserit Litany Against Fear and remember that it's just fear. Let it pass through you and you'll be remaining, and it won't. First story, Circle CI earlier this year announces they're rotating their secrets kind of out of nowhere because, well, turns out an attacker had infiltrated a development system from a remote developer, implanted some malware, and started stealing secrets that it could find in plain text laying around in code. Exfiltrated that info, started using it to get into customer accounts and start getting their data. The same day they report this, a independent researcher says, hey, my honey tokens were going off. This makes sense now. So we know that you can put honey tokens in these kind of places and see that, hey, someone's messing around and they shouldn't be. Uber, a kid from the Lapsus group, fishes a super admin's password, gets into the system, finds PowerShell scripts full of credentials, finds code full of credentials, and starts attacking other systems, gets into their Slack, taunts them, they don't believe him, he goes talks to the New York Times. Toyota, well, there's a subcontractor working for T-Connect, pushes the source code into a public repo, takes him 5 years to realize that he did that, and that source code contained a data key to real customer data. So over 296,000 customers' emails and other personal identifying information was exposed. AstraZeneca, user error caused real data to get moved into a test environment. The test environment credentials were exposed for over a year. They've never said exactly who was affected publicly that I know of. If you're an AstraZeneca customer, you should probably ask them about that. I think attackers are really only after two things. They're after machine resources to do their mining, and they're after data to ransom or to exfiltrate and sell, and to look through for any other tokens or credentials that will get them back to number one and number two. We see this in every one of those things I just talked about. That's the move, lateral slide into as many systems as you can get into. We find that that information combined with the state of secret sprawl, that's what we call a report every year, is a growing problem that we need to be able to start using this pattern of the attackers know that credentials get hard-coded. So the first thing they do is go and look for hard-coded credentials. This is a growing problem. 5.5 commits out of every 1,000 we see on GitHub public repositories contain some kind of secret. Attackers know this too. I mean, this is public data. We're in this constant cat and mouse game where we know how the mouse is about to attack us. And we, as the cats guarding the house, need to act so fast, anticipating that that it puts them on their heel, that they have to go back and rethink, what's my next move here? Is it worth my time and trouble to try to find a new way to get into the system? Every cycle they take to think is a cycle that you win. Playing defense will never ultimately win the game, but the more we can push them back, the longer they'll stay away from our data and our machine resources. So, cyber deception, that's what we're really here to talk about. Trojan horse, 1200 BC. This is a very, very short history. I thought I was getting a horse. What I got was defeat. Hey, here's a free horse for you. It's full of soldiers. Oh, no, here's a free horse. You get it in, and then you find out it's full of soldiers. So it wasn't what you thought it was, and you suffered the consequences. Sun Tzu, Heart of War, or the Art of War. Appear weak where you're strong, strong where you're weak. Ghost Army, one of my favorite stories from World War II. We don't have enough tanks to ship to North Africa. Let's blow up a bunch of tank balloons, inflate things that look like airplanes from a distance, and put some fake guns out and make a bunch of noise. They think we're fighting a war over here. In reality, we're sneaking our troops through over here and setting up for the real defense. First honeypot, go watch this documentary, The KGB, The Computer and Me. If you get nothing else out of this entire talk, go watch that. It's on YouTube. It was a Nova special from, I think, 1990. First honeypot. And basically, Cliff Stoll realized that if he kept an attacker in his file system for long enough, they could trace back to get a real phone tap or a phone trace to find out where the attacker was coming from. Turned out the attacker was the KBG, someone selling information to the KBG or KGB. Fast forward, let's take that idea and let's make a toolkit out of it. That we put honeypots out that machine resources that aren't in use, let's start making them into traps. Great idea. So good of an idea that in 98, Alfred Uger turns it into CyberCop, Sting, the first commercially available honeypot. Honeypots are heavy, though. Honeypots require entire system resources. System resources. You have to set up a machine. You have to set up a network. Augusto in 1998 said, I had this idea of we just had data that shouldn't be moving around, and if it moves, we know something's wrong. He called it a honey token, and I love that term. Canary tokens. There's a company called Thinkst that in 2015 added the ability to make fake AWS tokens into this public GitHub tool they were making, and they called it tokens, canary tokens. We're watching the maturity of this market till we get to last week at RSA, when Kevin Andian from Mandiant and Google Cloud says in his keynote, the State of Cybersecurity Year in Review talk at RSA, honey tokens are your early warning signs. You can see it on the screen right there. I didn't know he was going to say this. I was in the audience and be like, wow, we're on the right track with this thing. So very validating feeling to hear a thing you're talking about the very next week mentioned in a keynote speech. So this is how mainstream they are. Google's saying do it as your second line defense. So I've used the term honey token a lot, and I just said where it came from, but it really didn't define what it is formally. So a honey token is a decoy credential, doesn't go to anything, but there's no way to know if it's real or not until you try to use it. And when you try to use it, it just fails. But on the other end, it reveals you're there. It gives an IP address at least. Depending on what honey token you're using, they all do it slightly differently. But the important thing is, to the attacker, it looks real. If we're going to put them on their heels, we have to put out some traps. Hey, you use this. Your dwell time is about to go from however long it would take us to read the log and figure it out to a minute. Oh, wow, that IP address shouldn't be here. Let's disallow it. This is what the architecture looks like for one type of honey token. Honey token being a more general term, but this is one way to build them. We built this GG Canary. You can totally use this for free. It's open source. I'll talk about more options in a minute, but I just like this diagram. Let's set up a real AWS key with 0 permissions. Can't do anything with it. Never can. And we store those. Now let's set up a CloudTrail log that looks for people trying to use our account. If if the token is used, CloudTrail should report to a bucket. Bucket, then new entries in the bucket trigger a Lambda function. Lambda function says, hey, let's look through the log. Does it contain a canary token? If it does, hey, kick me out an alert. That's all it really is. Fake credential, some kind of mechanism that looks at usage of that token and then kicks out an alert if the token was used, and gives you all the information that you can pull out of things like CloudTrail in this case. So you can build these yourself. If you got time, if you got the resources, if you just want to, I'd encourage it if you're a researcher, or you can just buy these off the shelf. So DIY route, again, there's the architecture diagram. You could go from there. Thinkst makes canary tokens publicly available, but you have to run it with some Docker experience. Space Siren is an open source project, and if you know AWS deeply, it's a pretty good solution. It's the successor to Space Crab, which was, you can go do your own research. Space Crab's dead. Space Siren took its place. And then we make GG Canary, but I talked about that one already, so let's not get into that. There are off-the-shelf options that range from free, but not completely open, to all the way to very expensive. So canarytoken.org, completely free Honey tokens off the shelf. You can go create them for AWS, for Word documents, for a lot of things. If you're doing onesie twosies or you have special needs, it's probably a good way to go. If you need to do that at scale, Thinkst makes canary.tools. It's a commercial version, very straightforward pricing, very, very scalable. For our customers, we have Honey Token module. It triangulates the Honey Token data with data about your hard-coded credentials throughout your repositories that we're monitoring. It's in beta at the moment, but it's, we think, a really good tool. Microsoft Sentinel works with Azure. As far as I can tell, it's specific to Azure. If I'm wrong on that, please let me know. I didn't investigate it that deeply because I'm not a Microsoft person. Sorry, Microsoft. CrowdStrike makes Honey tokens now. So if you're a CrowdStrike customer, go talk to them. I'm not here to sell you CrowdStrike. Honey tokens can be used in a number of ways. We feel as a team at GitGuardian that there's some specific best practices, and that's what I want to share with you. Put them in your private environments, not just your code. Anywhere where you think, hey, if someone tried to mess around there, I should know about that. Even if it sounds dumb, like I put an AWS token in Slack just to be a private Slack message. We'll see if it goes off. So far it hasn't, because, well, pretty secure system. Put it in Vault, because why, if someone is in Vault and shouldn't be, you need to know about that. If an internal person's trying the doorknobs, why are they doing that? Maybe you should have that security conversation with them. Use a 1-to-1 ratio. 1 Honey token per environment, 1 token per use case, 1 token per job. That way, if it goes off, you don't have to think, well, what else was it shared with? Was it in all of these? I don't know. No, it's clear. This went off, that environment was affected, and now you know where to go. Use automation. You can do this at scale using a little script. I wrote an example script to kick you off. I used some tooling in there. Feel free to look at it. It's just an example. It's not even really for production release. It's just a script I wrote for my own personal use. Happy to answer questions about it if you have them. But one-off Honey tokens are value for one-off use cases. If you're going to do this at scale, make sure you're putting Honey tokens everywhere all the time consistently. And the only way we can do that consistently is with robots. And that's what scripts let us do. Think in terms of blue team. You're not there to hunt them down and invade their house if they've attacked you. No, you're there to keep them away from your data and away from your machine resources. Remember, this is a journey, not a one-off exercise. So start slow, start small, build up the skills, get comfortable with the tool, and then expand. Do not list Honey tokens publicly. They're just going to get a bunch of alerts as they get scanned. You can, but you're wasting your time. Don't go hunting the attacker unless you're law enforcement and that's your job. I already kind of talked about that. Stay on the blue team side. So in conclusion, we're in a cat and mouse game. We need to act fast, faster than we are right now, to keep them at their heels so we keep our data safe. Make them think what's next. If they think what's next, you're winning. go ahead and use Honey tokens wherever you can. Build them or buy them, or use the free ones off the shelf. I'm Ben Dwayne. I live in Chicago. I'm a developer advocate. Hit me up on social media. I'm happy to chat with you about just about anything. And thanks for coming to my talk. If you have questions, hit me up on the internet. I'm happy to talk to you. And thanks again for having me at HashiTalks Secure.
I love the idea of honey tokens.
I know. I didn't know they existed. I always thought they were honeypots, and now I know there are honey tokens.
Security just got easier and harder at the same time.
I'm not sure. I mean, you know what? It's we all say security is hard, but we're getting better at it. I think it's iterative. Fortunately, I think we're getting better at it. We're thinking about how to automate it. So
I've been telling people it's a team sport. It's not that team that has to solve it. It's not your team that has to solve it. We all need to solve it together. It's the only way it will work.
Exactly. All right. So we have our final talk for the day. It's a two-parter. So that's really fun. And there have been a lot of punny jokes in chat, which I don't really appreciate as much, but they're kind of entertaining. But this next talk is so punny. It's about pushing the boundary of Nomad. So they're some of my two favorite folks to work with, Nick Jackson and Rob Barnes, and they're going to talk about providing remote access to workloads and talk about how to configure Boundary, Vault, and Nomad to do so. Rob and Nick, to you.
Hey, I'm Rob Barnes. I'm a senior developer advocate here at HashiCorp, and I'm also joined by Nick Jackson.
That's me, Nick Jackson, developer advocate at HashiCorp too.
Welcome to the first of two sessions that Nick and I are doing here at HashiTalks Secure. The sessions that we're doing are going to be centered around Boundary and integrating that with Nomad. And in this session, we're going to focus more on the Boundary side of things. If you've never heard of Boundary, Boundary is a session access management tool. We're going to deep dive into what some of the problems are that we face as engineers and how Boundary can solve some of these problems for us. So let's look at this in practical terms. So here we have a very typical setup that most engineers would have encountered. We have a couple of private subnets. We have workloads within those subnets, and because they're private subnets, we do not allow any ingress into these subnets, which is fine. And as engineers, we probably should not have access to production workloads that are inside these subnets until something goes wrong or until we need to perform some sort of task as part of our role. Now, the way that we typically do this is we use constructs like a Bastion host, or we use jump boxes, or maybe something like a VPN. If we start looking at, say, the jump box example, we can look at some of the challenges that are involved in that. So the way a jump box normally works is you have a machine which is within that private network, and there is an ingress allowed onto that VM. The idea is that you can, SSH to the VM, you can authenticate, and then once you're on the VM, you're now within the network and you can jump from that machine to your target workloads. Now, the challenge with that is, in order for me to authenticate to that jump box, we typically use things like SSH keys. Right? So we'll place our SSH key on this jump box, which means that we can make our SSH connection to the jump box, and that's our authentication complete. And now we can jump to our intended target. But that lifecycle of the SSH key doesn't always tie to the lifecycle of my employment at the organization, for example. So anyone that's used this approach before, I'm confident if you go to companies that you worked at many years ago and your SSH key has not changed, you probably still have access to their production networks. Right? So we have this challenge of managing the lifecycle of the identity that we put in the form of the SSH keys, and tying that to the life cycle of our employment at an organization. The second big challenge that we have is, once I'm on the network, if there are workloads within that network that I'm not supposed to have access to, there's nothing preventing me from jumping from the jump box to these targets that I should not be going to, right? So when we think about the principle of zero trust security, we have to assume that our networks are already breached, right? And that by the very premise of me getting onto the network via a jump box, that's me breaching the network. Because even though I typically could be a trusted individual, this is a very high trust approach, and this is not the approach we want to be taking. If I become a disgruntled employee, I now have the ability to jump to targets that I shouldn't be able to get onto and cause mayhem, which is some of the things that we need to avoid. And that's even a malicious thing. Sometimes it can be as simple as I've jumped to the wrong box and I'm doing something which is intended for another box and it ends up causing disruption. So we need to put a model in which is zero trust rather than high trust. And with bastions and jump boxes, it becomes very difficult to implement this way of working. So if we look at how Boundary can help us solve some of these challenges, here we have a basic overview of our demo architecture, right? And we'll walk through this, and as the demo goes on, Nick will do a demo. You'll see how Boundary can solve some of these problems for us, right? So Boundary is made up of two components. We have the Boundary controller and we have the Boundary worker. Now, the controller is the brains of the operation. It's the thing that as a user, I authenticate to. So it will manage all the identity and so on and so forth. It's the component within Boundary that will decide whether I am authorized to access a target. So it does the whole access control part of the model, all within the controller, right? And then when I want to create a session to a target, the controller will also schedule that. But when we say scheduling, it schedules a worker, which is the second component. So the worker does all of the heavy lifting of, the proxying and the tunneling between your private networks and the machine that you're trying to access it from, right? So in my case, it would be my laptop, right? So those are the two main components of Boundary. So if we look here, what we have is we have our controller in HashiCorp Cloud Platform, or HCP. And the nice thing about that is now I don't need to manage this controller. I don't need to do any upgrades on it. I don't need to manage operating software upgrades and so on and so forth, all the patching. That's not my concern. HashiCorp will take care of all of that for us. So that's all managed within HCP. And then what we do is we install we add workers to all of our private networks. And these things will connect back to the controllers in HashiCorp Cloud Platform. So if you look at our diagram, we have three subnets here. We have a front-end subnet, we have a back-end subnet, and we have another subnet which we're calling Vault, right? These are all private subnets, so they should not have access to the public internet. There'll be firewalls in place to make sure that from the public internet, you cannot access things within there.
So I think Rob has really sort of eloquently explained the problem that we have. So let's kind of start digging in and let's look at some of the solutions. So what I want to kind of show you in this demo is how we can connect to virtual machines using Boundary and Boundary HCP. And this is kind of the setup that we're going to have. Because I think there's a way that Boundary works. It's got a very, very elegant solution to the problem of ingress into those private VPCs. So we kind of already explained that we were going to use the HashiCorp Cloud Platform. And the way that works is you have the Boundary controller and you also have a number of workers. Now, the workers are the things which broker the connection. So they handle that connection and they send it on to the destination. The problem that we have in our setup is that our kind of VPCs, our front end, our back end, and our vault, well, they're all private. There is no ingress rule into these VPCs. And we certainly don't want there to be, right? We want to kind of keep things as very simple as possible. So the way that we get around this with Boundary is that we use this concept of a private worker, which you can see here deployed in each of our VPCs, and multi-hop workers, and what they actually do is they punch outwards. So the private worker here in front end is going to make an outbound and egress connection to the public cloud worker, which therefore allows us to have that tunnel inwards, right? And it kind of works very, very elegantly because configuring those egress rules is a lot sort of more straightforward than having to have sort of a lot of the public ingress and from this, and it's just going to confuse things. And you're going to see how brilliantly this works. So anyway, enough talking. Let's get into the demo. So if we look at the configuration, and this is just an example configuration here for Boundary. We're gonna kind of go through and we'll generate this from a script. But this is our Boundary configuration. Now, as a very basic Boundary configuration, you need these 3 sections here. So we need the cluster ID. And the reason we need the cluster ID is because we're using HCP. Now, you could use OSS Boundary, but to be honest, the capability around using the multi-hop workers that we kind of just talked about and showed in the diagrams there is fabulous. And HCP Boundary, you can get a free trial, and it's just so much nicer as a kind of a use case. It means we have to configure a heck of a lot less. The other benefit of using HCP Boundary is you don't need to specify the location of your boundary control plane, your boundary cluster, because when you're using HCP, it just knows where all of that is. So what we do is we give it the cluster ID. Now the kind of the cluster ID is exactly the same ID. You probably can't really see it here, but it's it's in the URI there of my boundary HCP user thing. So we're gonna set that. Now I'm not going to paste this in at the moment, but I'll show you how we're going to set that in a second. And then what we're also going to do is we need to specify a listener. So the listener is the address for the worker where it's actually going to listen to, and this is so other workers can actually connect to it. In our instance, we actually can set this to just be localhost because we don't want any other workers to connect to it. But we specify the address there, and we have to specify the purpose. Now, the kind of the boundary CLI or that we're going to use, the boundary command, actually has the capability to run as a control plane, as a worker, various other different bits. Now, we're just going to use worker, so we set the purpose here to proxy. Then we've got to specify some of the worker configuration. So the worker configuration is specified here in this worker HCL block. We're going to give it the auth storage path, and I'll explain what that's going to be in just a second. We're going to give it an activation token, a controller generated activation token, and some tags. Now let's break this down. So when you're authenticating to Boundary from the worker, there are 2 different approaches that you can use to authenticate. The first one is controller-led. And with controller-led, what you do is you generate a token inside of the boundary control plane, and you give that to the worker. The worker uses that token to do the initial authentication to Boundary, but what it does is it swaps it for an authentication payload, which contains the actual authentication token and also the certificates that are needed to connect to the boundary control plane. So it's going to automatically configure itself with TLS. It stores that information inside of auth storage path. So in theory, you got to remember is that this activation token here is one shot. It's single use. So if your worker restarts, then it can't use the activation token again. So what it's going to do is it'll fall back to reading the authentication version data from this auth storage path. So the auth storage path needs to persist as long as your worker wants to hang around. So if you're going to write this to temporary storage and you restart the temp folder, or you restore it to like a RAM disk and you restart your VM, when the VM comes back up, the worker is not going to be able to re-authenticate. So that needs to be persistent storage. The other thing to remember about this storage is it contains the authentication data for your boundary worker, so it needs to be secured. The only thing that should have access to read from that is going to be the boundary worker. So it needs to have the correct file permissions and file paths that no other applications or processes on the machine can actually read from that and potentially cause you a vulnerability. The tags, what we use the tags for is whenever we're creating a target, and we'll kind of look at this in a bit, we can actually we can specify that this target is linked to a particular, or can be reached by a particular worker. And that's why we're going to specify the tags here. So we're specifying this as front end, and this worker is going to be able to service any of our front end applications. So that's the worker configuration. Now what we need to do is we need to generate this. Now, there's kind of a number of steps we need to do. So first thing is we need this controller generated activation token. Now, the controller generated activation token, we can actually generate just using the boundary CLI. So we can use a command like this. Now we're going to do boundary workers create controller led, and it's going to generate us a token. Now, in order to do this, we've got to be authenticated against the boundary control plane. So I've already authenticated, and I've got my authentication token here in boundary token. But we'll get into this when we start putting the script together. We also are going to need to manage that authentication. So let's just run this to see how it works anyway. So you can see there that's going to give me back an activation token, and then I can use that inside of my configuration file here to do the authentication. So that's kind of like on the face of it, right? That's fairly straightforward. But we do need to actually authenticate first. And to authenticate, what we can actually do for a machine is we can just run the boundary authenticate command. So the boundary authenticate command, we're going to use the password. So inside our boundary organization, I've got this one here set up as HashiCorp. I have I can configure users, and I can configure groups and roles that have access. So we can kind of use that to register our worker. And you can see here, actually inside of the CLI, this is the worker that's just been registered from the command line. Because what's important to remember is that when you execute the command to create a worker, it generates a token. It also sets up the worker in a stub in an unconnected state inside a boundary. So obviously it's never last seen. It doesn't have a release because the worker hasn't connected. So I'm just going to clean this up and remove that. And we'll come back to that in a little bit. So let's go through. Let's build an authentication script that we could use from systemd or another sort of init process, which is going to authenticate our boundary worker. So I'm going to create a startup script here, and in the startup script, it's just going to kind of use bash. I'm using -e there for error correction, but let's add some variables just to kind of set things up, and we can define those variables here, right? So what I'm doing is I'm gonna need to make this script somewhat dynamic. Now, so I'm going to configure it from environment variables. So I'm going to have environment variables on the machine, which I could set with cloud in it or whatever, to be set to the worker name, the cluster ID, the username, the password, and then importantly, I need to set the authentication method ID. The authentication method ID is going to be different. You can have multiple ones of these set up, because in terms of the way that kind of boundary works, you've got the ability to have obviously your organization, and then inside of organization we have projects. So there's a kind of a number of different ways that you can kind of configure the user access. Then I need to set my base URL, because I'm going to use the boundary API to do all my authentication and stuff like that. So I'm going to set that. It's very formulaic if you're using HCP. It's always going to be your cluster ID.boundary.hashicorp.cloud, and then your auth URL, which you can use, and we'll see how we do that, is basically the base URL / auth methods, the auth method ID, and then the kind of the control that we want to invoke, which is authenticate. So once we've kind of got those variables set up, then what we can do is we can actually do the authentication itself, is this command here. So let's have a look at this. So I'm just echoing what's going on so we can see for some debugging, and I'm going to generate an auth request. Now boundary, the kind of the API, you're going to post it a JSON payload. So in the instance of the authentication, I'm going to post it a JSON payload, which has a top level of attributes, and then it has a login name and a password. And this is going to be the user inside of the the boundary authentication there, which is set up there. That's going to return me some information. Now, if I kind of do the authentication manually, let me just kind of show you. Let me just redo that. So let's just have a look at this as if you were going to return it as JSON. And you can see there that it kind of returns you a JSON payload. Let me just make that a little bit clearer and really? Let's return that JSON payload and let's pipe that in a JQ. So you can see there, this is the data that's going to come back from Boundary. There's a lot of editing that's going to need to go on here. And we get the token. So we get the token there. And what we're going to do is we're going to use sed, and we are going to parse that out. And we're just going to grab that token and we're going to store it in a variable. Now, if you were using JQ and you had JQ installed on your machine, then you can make that easier. We're building this script up using sed because it's pretty much got the lowest common denominator of all of the software that could be installed on a base Linux instance. So once we've grabbed that authentication token, we can use that to generate the controller-led token. So the controller-led token is going to look like this. So again, we're making another API call. This time we're making that call to the token URL, which is boundary v1/workers create controller-led, as you can see here. And what we're going to do is we are going to use the bearer token header, passing the token that we just created from the authentication request. And we're going to generate our controller-led token. Now, our controller-led token allows us to specify some criteria, such as the name of the worker, which is really nice rather than it being random assigned. So we're going to set that as a payload. We're always setting the scope ID to global because workers are always attributed to a global scope, regardless of the number of projects and things you've got available to you. Is that true? It is true, isn't it? Anyway, and then we're going to specify the name. And the name here, we're just setting from a variable. That again is going to return us a JSON payload, and we're going to use sed to get that activation token out of there. Now, the worker ID is also returned from that JSON payload. And the reason we need to store the worker ID is that whenever we deregister the worker, so whenever the systemd job shuts down, or we want to deregister the worker because we can create these semi-persistent workers now. So we're going to grab that and we're going to just dump that in a file. So the next thing, once we've got that controller token and the ID, what we can do is we can actually generate the configuration file, this one here that you saw earlier, and we'll just write that to a file. Now, we're disabling mlock here just because we're running this example in a Docker container, but you probably want to kind of say you always want mlock to be disabled because you don't want anything to be written to RAM disk, any tokens or memory like that. We're specifying, the boundary cluster ID. Again, that's going to get picked up from our variable that we are loading. The listener is standard. The auth data is as we had it before, and then we're just using that token that we created in the previous step. And that's going to generate our token. Now, the next thing that we want to actually do is to look at the deregistration script. So let's have a look at a deregistration script. You can see what's going on here. Now, with the deregistration script, what we're going to do is we basically want to take the worker that we created in the previous step, and we just want to just shut it down and clean up after ourselves when the machine shuts down, because it'll obviously create itself every time the machine starts if we have that in a systemd startup job. And we can set that here. So again, we're doing the same things. We're just setting we're going to authenticate, and then we're going to call the deregistration URL using the worker ID, authenticate to boundary, grab the token, and then run that deregistration call. And that will clean up after ourselves, and we'll also remove the auth data there, so there's nothing left lying around. For our simple example, because we're not going to be actually using systemd, what we can do is let's just put this at the top of our script here in a trap, and then whenever this script process is terminated, or it receives a sigterm or a sighop or anything like that, it'll automatically call deregister. And that's just because we're going to run this like nice and simply. Right, so now we've got everything there. The last thing we need to do in our startup script is we need to actually run the server. So we're going to do, we're just going to basically just run boundary worker server. We're going to specify our configuration that we're writing here. And then we're basically just going to grab the PID there. And then just, we can basically just wait on that PID, which will kind of just be our nice little script there. So then we can run it. So let's go over to our terminal and let's run our script. So I'm just going to do run a script, startup. See there, it's generating the token for the boundary worker. It has called the boundary API, set everything up, and we can see there now that the boundary logs are streaming in. So I'm going to bounce over to my workers. You can see now there we've got our boundary worker front end that we've just created, and that's up and running, and that's pretty awesome. So the next thing that we want to be able to do is to see how we can now use this boundary worker and connect to use it to connect to the SSH on that virtual machine. All right, so we've got a boundary worker now running, which is running here. So what we can do is, because this boundary worker is running in the same subnet as our virtual machine, we can actually use it to be able to initiate an SSH connection to that VM. Now, to be able to do that, what I need to do is I need to create a target. So I'm going to create my target. I'm using this command, boundary target, create TCP. The token, I need a token to authenticate the request, and that's just my auth token. I'm going to give it a name. I'm going to call this VM TCP, because we're creating a TCP target. Now, a TCP target is basically just a very dumb target. It's just going to proxy any traffic that you send it to the destination using TCP. There's no cleverness going on here. I'm going to give it a description, and that will kind of show up in my boundary UI, and I'm going to specify the default port. And the default port is port 22, and then the address. So this is the address by which the boundary worker can reference the virtual machine. So it's an internal address, and that for our machine is VM container shipyard run. And of course, we're going to specify the scope ID to which we want to create this in. And then this is the kind of the magic sauce here. So this is the egress worker filter. So the egress worker filter is the worker which can handle this request. If you don't specify the egress worker filter, HTTP is going to try and use the public workers, and the public workers have no access deep into my network to be able to do this. So I've got to specify the egress worker filter, and that's going to be front end. So let me run that. And you can see there that it spits out a bunch of information there, including the ID, obviously the scope is boundary demo, and you can see that inside of the UI as well here. So let's just go here, go to our boundary demo project, and then if we look here, we can see our target VM TCP. It has all of the bits and pieces. Now you can see here that we're using a private network worker, so an egress worker host, and then the name, which is front end. So the name, it picks that up from the tags, which is on the worker. And that was what we set up in our boundary configuration worker config here, these tags. Right. So we've got that running. Now that that's running, we can actually use that to make a connection. So let's use that and create that connection. To connect over SSH, what we're going to do is we're going to use Boundary Connect SSH. Now, Boundary Connect SSH is just a helper. The SSH here is just a helper function. What it's going to do is it's going to launch an SSH session for the target. So the target ID, let me just grab that here, and we're going to run that. And what you can see is we'll run that there. Now, it's just running, it's created that SSH session. So we've got the connection there. Do you want to continue connecting? Yes. Now it's asking me for the password, and the password, well, I don't actually have the password there. So let's run that again. But this time, let's run it and let's specify some additional information. Now what I can do is I can specify some additional information that I want to pass to the connection helper here. And this is basically just the flags that would get added to the SSH command. So I can specify the user as root, and I'm also going to specify the private key, which I've got here in this file, front end files, SSH keys, IDRSA. If I run that now, it's going to make that connection. So that connection is going from my local machine to Boundary and HCP, and then it's going to route its way down through the local worker that we've got running here, and then it's going to establish that session.
Okay, so we've been able to make our SSH connection using Boundary, but there's a small problem. We had to specify the username and we had to give it the SSH key. Instead, what we want to do is we want to see how Boundary and Vault can work together to transparently inject that SSH key, which we can get directly from Vault. Now, to do that, we have to change a couple of things that we did already. So we already created a target, and that was a TCP target. But instead, what we want to do is we want to create it as an SSH target. Now, this gives us some magic that allows us to inject the credential at runtime, right? So it's the same kind of command. It has all the same details in there as what we had before. The only difference is we're specifying a type, which is SSH. So we run that and it's created the target just as we've seen before, right? If we head over to the UI and we have a look, we can actually see that we've created a new target. Okay, so now we've created our target. What we now need to do is we need to create the actual secret in Vault. So we need to create the SSH key. Now, how to do that is it's a special type of secret we need to do. It's going to be using the KV secrets engine, but we need to specify two keys in there. The first is the username, which will be root, and the second will be the actual SSH key itself. Okay, so now we've created the secret, we now need to create a Vault policy. The Vault policy has to do a couple of things. Firstly, it's going to need to be able to access the secret that we've just created. So we have a policy here which leads to the exact path that we specified for creating that secret, and it gives it read permission. We now need to create another policy, which we're calling the controller policy. Now, this is the policy that's going to allow Boundary to be able to renew its own token and to look up its own details and just generally manage its lifecycle of its relationship between itself and Vault. So we have a few different things here. The main thing is it can revoke itself and it can renew its own leases. Okay, so now we're writing these policies to Vault. And if we could just do a quick lookup just to make sure these policies exist, and we can see we have the controller secrets and the controller token policies. So in order for the controller to be able to speak to Vault, it's going to need a Vault token. So we're going to create a Vault token with these policies that we've just created within Vault. It also is going to need to be an orphan token. It cannot have any inheritance of any permissions of any parent token. One final thing is it also needs to be a renewable token. Like Boundary is going to need to be able to renew itself when the token expires. Okay, so now we've created that token. We can see that in the output where it says client token. So the next step is we actually need to create the actual credential store within Boundary. So we have two types of credential stores. We have a static credential store and we have a vault type of credential store. We're going to use the vault one in this instance here. We're going to need to give it some details like address, and we're going to need to give it the token that we've just created as well as some other details. Okay, when we create the credential store, it's important to note that it's actually the controller that is going to speak to Vault in order to obtain the credential. It's not going to be the worker, right? And so as such, we need to think about the connectivity between our controller and our Vault, which is in a private network. So if we create this credential store here, and we hit enter on that, it's going to hang. It's not going to be able to make that connection to Vault, simply because it has no way to be able to connect to Vault in a private network. So in order to do that, what we have to do is we have to specify a egress worker tag. We need to tell it exactly which worker it needs to use in order to speak to Vault in our private network. So if we kill this command here, okay, so when we run this command, but this time add the worker filters and we tell it exactly which worker to use, we should be able to create the store because it's able to make the connection to Vault and it's able to verify the connectivity details. And there we have it. So we have this output here, which shows that it has now created that credential store within Boundary. So now we've created a credential store, we now need to create a credential library. Now, a credential library is just a reference to a Vault secret. We need to tell it exactly where to look in Vault in order to obtain this secret. So here we're going to tell it the credential store ID, which is the one that we've just created. We need to tell it the path within Vault in order to make the call to retrieve the secret. And we also need to give the library a name, right? Now, the credential type that we are using this time is SSH because we want to inject the SSH credential into our sessions when we do that. So if we just run this command here, this will create our library for us. Now, if we have a look in the UI, we can see that the credential library has now been created. So the next thing we want to do is we need to associate this credential library with the SSH target that we created before. Okay, so to associate the credential library with our target, we need to run this command here. And all we're doing is we're going to add credential sources and we need to grab a couple of IDs. So we need the ID of the target within this command, and we're going to need the ID of the credential library, which we're calling credential sources. So we'll just grab that and we'll paste that in here and hit enter. And now that has created the association with the credential library. So now if we have a look, we should be able to see that in the UI. If we look at the target, there we go. Now, let's test this out. So if we run Boundary Connect, but this time, instead of us having to specify the username and the SSH key, it should automatically inject this into our session. So when we run the command, we should be straight into the VM. And there we have it. We are in. So what we've done is we've shown how Boundary and Vault can work together to automatically inject credentials into the session, with us transparently not having to know what that credential is.
So I think you'll agree that was some pretty interesting stuff that Rob's just shown you. Now, stay tuned because we will be back later on with part 2, where we're going to kind of start digging into Boundary and how we can handle things with dynamic workloads in Nomad. So welcome back to our second part. And in this session, what we're going to do is we're going to concentrate on dynamic workloads. So we're going to show you how Boundary workers can integrate with Nomad Scheduler and how we can actually run Boundary workers in an easier way when they're running in highly dynamic environments. All right, so we've already seen some pretty interesting things, I think. We've seen how we can use Boundary to connect just to a virtual machine via SSH and how we can inject Vault credentials. But now let's have a look at how we can deal with sort of ephemeral workloads, such as when you're running in Kubernetes or Nomad or other sort of dynamic environments. And we're going to kind of run through this in a couple of different parts. The first is we're just going to show you how to actually run Boundary workers on side of Nomad so that we can provide access to those workloads. And then we're going to kind of tackle a bit of a problem which is what do you do when those targets are constantly changing? So the IP addresses, the ports, they're running in a highly dynamic environment, then they're always changing. So let's first look at kind of an overview of what we've got. So what we have is a Nomad cluster. Now the Nomad cluster is comprised of a server and 3 different clients here. Now, if we want to provide access to any of these applications, which is running inside of this Nomad cluster, we could potentially just publicly open that up. Well, that's not a good thing. We could work out how we can kind of like, get onto the node itself. And then, that again, from a security standpoint, that's not a good way to do it. What we want to be able to do is we want to be able to use the kind of the sandbox security capabilities that Nomad has for your applications. And we want to be able to kind of just be able to inject a connection direct to that without being able to expose any of the other applications running on this particular node or any of the other nodes. And to do that, we can actually use Boundary. We can run a Boundary worker on each of the nodes, which would allow us to be able to define a target and then, create a connection to any of those applications. And that's the kind of the first step. Now, I think the key thing around this is that we ideally want ephemeral workers, right? Because the approach that we've taken so far is that we kind of register this worker. It has a kind of a known name. We're giving it a username and password, which is somewhat static, and that's not an ideal way to kind of go about it. We want to be able to do a controller-led approach in terms of registering our workers, but we want to be able to do it fully dynamically. And to do that, we're going to use a Vault plugin, because there's a Vault plugin which we've written, which enables you to dynamically generate these sort of Boundary workers and the controller-led tokens that is needed to connect to them. So we can use the built-in mechanism that Nomad has to be able to identify a workload. We can use that to authenticate against Vault. Vault then speaks to Boundary to generate the controller token and do the initial registration of the worker. And then, of course, we can just go ahead and start the worker. And it's a very elegant solution, and it's pretty cool, and it works 100% with the dynamic scaling and the fact that a worker inside a Boundary is not going to live forever for Nomad. The job could get killed, the node could disappear. There's a number of different reasons why this is highly shifting. Anyway, enough waffle. Let's have a look at the demo and see how this works. What we've got here is a Nomad cluster, and there's no jobs running on this Nomad cluster. But what we're going to do is we want to run a job on this Nomad cluster, and we're going to be able to get secure access to it, even though the Nomad cluster doesn't have any public access whatsoever. So how are we going to go about doing that? Well, the first thing that we need to do is that we need to be able to run a worker inside of our Nomad cluster. Now, to run a worker inside of our Nomad cluster, what we could do is we could go through that whole process that we did before, where we had these kind of startup scripts and, we could have all of this in a job, or actually we could use a Vault plugin. So let's have a look at how we can simplify all of this by using the Boundary Secrets engine for Vault. So to use the Boundary Secrets engine for Vault, what you need to do is you need to first download it, and you can download it from this URL. And then we'll kind of install that inside of Vault, and we're gonna be able to run it. So it's just going to be Vault secrets enable Boundary. So the kind of that standard way of enabling a secrets engine inside of Vault. And then what we actually need to do is we need to configure it. So to configure it, again, like any secrets engine in Vault, we're going to write to the config part of the path. And it needs certain things. So Vault needs the ability to be able to talk to Boundary, in this instance, Boundary HCP. So it needs the address of the Boundary cluster, it needs the login name, and it needs the password, and also the auth method ID that it's going to use to authenticate. Now, in order for this to work, Vault needs sort of fairly permissive control over Boundary, because it needs to be able to create controllers. controller-led worker tokens, and the kind of the setup for how you configure all of those user IDs is in the script there, which you can find in the README. So we're gonna run this, and we're gonna run this and just configure it. So this is, again, it's using my HCP boundary setup here. So we've configured that worker thing. Now, in order to be able to generate controller-led tokens using Vault, what we're going to do is we're going to create a role. So again, this is, you know, pretty standard Vault stuff. So I'm going to create a role. I am calling I'm putting out the path, calling the role worker. I'm setting a TTL and a max TTL. So the TTL is going to be the maximum duration that the worker will exist for. So it's going to be 36. That's in minutes, isn't it? Is that an hour? Seconds, yeah. So there's an hour. And then we're setting the max TTL, which is like how often the lease can be renewed. So we're just setting those again to an hour. We're setting the role type. So the role type is worker, and then the scope that the worker will be registered to, which is going to be ID. Now, once I've created that, what I can actually do is I can use it. So if I do vault read boundary creds worker, and then specifying a name for my worker, and I run that, Vault gives me back an activation token that I can then use to register a worker. If I go over to my boundary cluster instance and look at my workers, you can see there we've got our local worker. It's been generated by Vault, and that's all set up there. Now, the nice thing about that is because Vault is managing this, I can actually revoke it. So let's just do Vault lease revoke, give it the name of the lease there. And then if we go back over to the boundary UI and then have a look at our workers, let me just refresh that. You can see there it's gone because Vault's managing that worker instance now, which is really nice. So what we are going to do is we're going to use that with Nomad. So we're going to get Nomad's Vault secrets to be able to generate that worker token that it can then use to start our worker. So in order to create secrets for the worker, again, Nomad is going to need a policy. So let's have a look at that policy. The policy is going to just going to be called worker policy, and it's going to look like this. So we're going to create this worker policy, and this will give Nomad the ability to generate those credentials. So we need to write that to Vault. So let's do that. Okay, so we're going to write that to Vault. And then what we can do is we can actually create our Nomad job for running inside of Nomad. So let's create a new file. And let's save this as boundary worker. So let's do file, save as worker.hcl. So this is the basic Nomad job. So all it's doing is it's using a very simple setup here. So let's go through and let's build this up. So what we want to be able to do is we want to be able to inject some secrets into this job. So we are going to add the vault stanza. Now the vault stanza, what this is going to do is this is going to tell Nomad that it can use this boundary worker policy, and it has that available to it to be able to get some secrets. So the secrets, what we're going to do to be able to use those, we're going to just use a standard Nomad template. So the Nomad template is going to look like this. So let's just run that. And you can see there that we've got that Nomad template. So it's exactly the same as the configuration that we created earlier. I'm just setting the cluster ID there. But rather than having that that controller generated secret injected from an environment variable, we're using Vault template here. So we're specifying with secret, boundary creds worker, and what we're going to do is we are going to use the worker name, and we're going to set that to the Nomad allocation ID. So we're using this function here, env, and we are piping that into the template function printf to be able to generate the worker name inside of the template stanza. So it's just a little bit of a workaround to be able to generate dynamic parameters for our Vault secrets. Tags, just setting the environment there in Nomad. And then what we're going to do is we're going to specify our configuration. And the worker config is going to look like this. So the worker config, we're actually going to use the boundary worker HCP 012, and then we're specifying the command, which is going to be server config, and then the path of the config is local config, and that's what we're generating here with this template. So we can deploy that worker now to Nomad. So let's run that. We are going to do Nomad run, and it's going to be worker.hcl. So we can see there that job's getting triggered. Let's bounce over to Nomad and let's just refresh that UI. We can see there that we've got the boundary worker. The boundary worker is pending. This is going to start running in just a second. Okay, we've got the task started. Let's just have a quick look at the logs. Brilliant. So you can see there that we've actually got it all connected up. We can see the logs that have streamed in. Let's go over to our workers in our boundary UI, and you can see there that that's our Nomad allocation ID. So the process that we've done is the Nomad template has used secrets from Vault. We've used the boundary secrets engine inside of Vault to automatically generate these controller generated activation token. We've injected that into our boundary worker in our Nomad job, and it's just started up. And of course, whenever we delete this worker, it's going to deregister itself as well. So that is all we really need to do in order to be able to now start being able to access jobs from inside of our Nomad cluster.
Okay, so we've been through the process of how we're going to use Nomad to register our boundary workers in a dynamic fashion. But what about our actual workloads, our actual application components? How are we going to go about handling access to these things here? So if we take a look at our Nomad overview, as we saw before, it's a very simple setup. I'm the job owner, I'm the developer, and I'm going to submit a bunch of jobs. And we have 3 different nodes here. So I have jobs going to different client nodes as per the requirements, right? The challenge here is once we've deployed these jobs to their nodes, how do we access the actual jobs via boundary? And this is where Census comes in, right? So Census is a tool that we're going to deploy in our Nomad cluster, which is going to register all of these jobs as boundary targets. So the way that works is this. We would submit our jobs to Nomad as usual, right? And when Nomad schedules those jobs, Census is going to listen for events in Nomad. And anytime a new job is registered or anytime there's any updates to the IP address or the port or anything like that, Census is then going to contact Nomad, is going to create a target or it's going to update a target with the connectivity information. Or if the job is removed from Nomad, then it will go to Boundary and it will remove a target. So essentially what Census is doing is it's taking an event-driven approach and looking for all jobs that we deploy to our Nomad cluster, and it will just register them as targets within Boundary. And this will allow us to do some of the similar things that we've seen in the previous session where we're able to create sessions to these workloads using Boundary, using local proxies and reverse proxies. Okay, so let's have a look at this problem in practical terms and actually just play this out, right? So we have Nomad here. Let's just run a job. We're going to run a job just to see exactly what happens, right? So we're just going to run this command, nomad run, and this is going to take the job file and deploy this to one of our client nodes. So here we have the job deployed. Let's take a look at that in the UI. So here we can see the job has been deployed. Now we need to get the IP address and port if we did want to connect to that. So we can find that right here. And that's no good because, you know, if we need to register that in Boundary, that's going to change all the time. We're actually registering this in Consul as well. So we can see it's automatically registering that service within the service mesh. But still, there's no way to automatically get that into Boundary, right? So you can see we're in Boundary at the moment and we don't have a target for this job, right? So how can we fix that, right? And the answer to that is census, right? So if we stop this job, we can have a look at how we can deploy census into our Nomad environment and see how this can automatically create the targets for us. Okay, so let's have a look at the census job file here, right? So the key thing in this job file is this config block, right? So essentially for census to work, we need to configure a few details here. And we're going to use the same technique we used with the Boundary workers using the templating engine, right? So the important thing here is we need to give it some connectivity details for Boundary. So as you can see, we have username, password, address, and some other details like org ID and auth method. And the easiest way to get that in is to store these things in Vault as a secret, right? So let's write a secret to Vault that contains all of the parameters that we require. Okay, and that's written there. Okay, so here we have the Vault policy that we need to write to enable Nomad to be able to access these secrets to inject it into the config file. So what we'll do is we'll write this to Vault just using this command here. Okay, that's successfully written now. Okay, so now that we've got the secret in place and we've got the policy in place, these are the prerequisites that we need for census. So what we'll do is we will deploy census as a Nomad job. So let's just run this. And now it's running. Let's take a quick look at this in the Nomad UI. And we can see in the standard out that everything is up and running. Okay, so now we have census running. All we need to do is actually stop the original job that we had and we can run it again. And this time census should spin into life and create the target. So let's run that now. Okay, that is now running. So if we head over to our standard out on the census job, we can see in the logs that it is registering the target within Boundary. And as we can see in Boundary, we now have an additional 3 targets, which is 1 for each node that we've deployed there. And that's all being facilitated by census, which is amazing. So now what we have is this automated workflow that every time we deploy a job in Nomad, or every time an IP address or a port is updated within Nomad, it will automatically keep Boundary's target list up to date. And that is pretty cool, in my opinion. It's something that automates the workflow and it just, reduces the overhead in terms of managing the relationship between all these different infrastructure components. So now that we have our targets automatically registered within Boundary, let's take it for a test drive. Let's try and connect to it in the same way that we did before, right? So we're going to do Boundary Connect and we're going to use the target ID and we'll also enter the token file that we need to authenticate to Boundary in order to make this Boundary Connect work. We'll just run that. And here it gives us a port that we can connect to on our local host, right? So the best way for us to test this is to actually curl localhost and use the port that Boundary has given us. So if we just run the curl command, so we'll curl localhost and it is port 40577, and we should get a 200 response, and we do. And that's actually a response that's coming via proxy using Boundary and the workers that's within our Nomad environment. So just to summarize, what we've done here is we've been able to deploy our workloads to Nomad. We've also deployed Census alongside that, which is watching out for any workloads that we deploy into our Nomad environment, and it's automatically registering them as targets to Boundary. This then facilitates us to be able to make secure tunnel sessions to our workloads via Boundary in our private networks. And that is pretty cool. That's probably the most secure way of being able to access your workloads within a private network.
Well, I hope you found that interesting. I think that concludes our talk for today. But I think we've shown you that kind of you can actually use Boundary as a really sort of good way to be able to get secure access to your systems, whether they're dynamic systems like Nomad or Kubernetes, or just kind of like static virtual machines. All of the kind of the example and the source code that we've shown you today, we'll put in the links. You can download this and try yourself. And of course, if there's anything, please reach out to us because we'd love to be able to help you out and chat about those. I think I just want to kind of say a big thanks to everybody who's organized HashiTalks Secure. It's been great to be part of it. We've certainly enjoyed ourselves. I hope you've enjoyed yourselves too. Until next time, from Rob and I, we'll see you all later.
I've definitely enjoyed myself. This was great.
Yeah. There was so much code on there too. I always appreciate a code demo.
Right? And a repository to actually check it out versus, yeah, I tried to make this work. No, here you go. Here's the code. Go check it out. Let us know. I like this.
Yeah, I appreciated the synthesis of all of the tools together, right? Boundary and Vault, using credential stores, but also being able to do some kind of like event-driven approach to access. That's pretty cool too.
It's hard, but we made it today too. It's the end for this year's edition, this year's first edition of HashiTalks Secure. So for those that missed something, what can they do?
Oh, yes. Definitely check out our HashiTalks Secure playlist. We'll have one compiled with all of the presentations that you saw today, as well as if you're interested in the presentation slides, go to discuss.hashicorp.com. We'll have the speakers be posting their slides on that thread.
And those speakers that are posting their slides, you can also ask them questions about their talks. Most of them were in the chat, but let's be honest, like for me, I'll go review stuff and then have questions about 6 hours after we close here.
Yeah, definitely follow up. And if you're interested in a regional HashiTalk or something, a virtual event that's happening, maybe you're interested in submitting to it, interested in, attending, check out the HashiTalks Hub. We have a number of them listed on there. We have a number of regional ones as well that are localized to specific languages. So check it out, see if there's one that's of interest to you.
There's so many left. Of course, today was Secure. We've got Africa coming up, Israel, from the top of my head, Brazil, built in August 9th and 10th, Korea, Japan. What am I missing? There's so many more. Just check out the URL, sign up, get great content for free, or submit your own session.
Yeah, and there's always the big HashiTalks too. The 24-hour event, that one's the big one.
Luckily, we are about 9 months out from that, but if you want to take part in that, best start thinking about your talk now. Never too early to submit.
No, definitely not. With that, I think, Karim, we're going to close out for today. I hope we see some of you at Hashi Days, whether it be Paris, Munich, or London. And we appreciate you joining HashiTalks Secure today. Any parting words, Karim, any security wisdom you want to offer to folks?
Yeah, don't ever show your root token on screen. Been there.
All right, with that, redact your root tokens, people. Thanks so much for tuning in, and we hope to see you at the next HashiTalks.
Have a good one.